must begin.
What you think that you think that you think that we think is cool. You think that you think that you think that what you think you think I think you think that we you think that we you think you think that we
But it's clear that it must begin.
Hello, 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 folks. Happy Sunday, everybody. Welcome to the stream. I am super pumped about this one today, guys. Can't wait to talk to you all about object-oriented programming and my favorite SQL. We're going to get started here in about 1 minute. Hi, Celeste. Hey, Runamucker. Hey, Rayquino. Welcome to the stream. Good to have you here. But yeah, I will see you all in just a little bit.
But it's clear that it must begin.
Hello, everybody. Hope everybody's having a great day. Right off the bat, we got a lot of new followers here in the last couple days, so just want to thank those folks really quickly. We have got, let me see, get them pulled up here. Plump Nest, Ubrax, Alex Soup, Doreed, Gaius Onoz, Anastasia Blackthorn, David Day, Beauty Craze, One Jade Emerald, Sahid, Zoberflute, Kwame 1984, Sally 30, Extract Official, Taper Cage, Pahu, Yafu Amans, Sagoon, Ade, Jehaz, and Brit BL. There were more folks too, they're a little farther out, but those are just the folks that have followed in the last couple days, so thank you all so much. And yeah, I hope you all enjoy the stream today. Alrighty, and as always, I know I sometimes forget to mention this, but if anybody wants or needs closed captioning for this stream, you can hover your mouse over the right side of the screen here, and you should see a little pop-up that you can click with a closed caption icon, and if you turn that on, you will get live closed captioning for this stream. So feel free to turn that on if you want or need it. But yeah, how's everybody's weekend been going? It's very cold here where I live, and so I'm happy to be inside streaming today. And I can see all the little fat songbirds outside my window sitting in a bush, and it's always fun to watch them. They're all puffed up for the winter, so they look like little tennis balls. It's pretty cute. Yeah, I love watching the little birds sitting outside this window here, and my bedroom window looks right out onto my bird feeders, which I always keep stocked up, so I can always wake up and watch the birds going about their business and watch the squirrels eating all the bird food out of the bird feeder. And yeah, I've heard that are squirrels, so I think, there's squirrels in the UK, but are squirrels like a thing in other countries in Europe? Do you all have squirrels? I genuinely don't know. I'm an ignorant American. Bear with me. Yeah, squirrels are huge in the USA, definitely. But are there squirrels in like Europe? Because I've been to the UK and I know that like, the London parks and stuff have squirrels, but genuinely asking. Hey, Diaztec, good to have you here. Also, I have a secondary follow up question to the squirrel question. This is also very important and vital to education and stuff. Is Jaffa cakes. So I just tried Jaffa cakes for the first time yesterday, and they are absolutely delicious. I love Jaffa cakes now. I got the orange flavored ones. They're not really a thing here in the United States, but I've always heard about Jaffa cakes from like UK shows, British shows and shows from the UK. And so I'd always heard about them, but I didn't know what they were until I actually found some at Aldi's, which is our version of I think it's called Lidl in the UK. Lidl. I don't know how to say it, but you have the same store in the UK as well. And so yeah, they sell Jaffa cakes there, and they're pretty delicious, and I love them now. I'm just wondering how common they are, in Europe overall. If everybody knows what Jaffa cakes are. Ah, Raquina says, I don't know if there are squirrels in other places of Europe, but in Spain there are wild pigs roaming around as squirrels would. Interesting. Okay. Yeah, we have wild pigs a little bit in the United States, but not so much. I know that wild pigs are big in other countries, like Australia has them, and yeah, Spain, I guess, has them. Interesting. Hey, Kamali, happy Sunday. Celeste says Google says there are over 200 species of squirrels that live on every continent except Australia and Antarctica. Interesting. Okay. Squirrels are native to the Americas, Eurasia, and Africa, but humans introduced them to Australia. Not surprising. We introduced a lot of stuff to Australia. Oh, you have the breaking stuff says, welcome to the stream, by the way, breaking stuff. We have the cutest squirrels. Called Nag Appies or bush babies from South Africa. Okay. Hi from New Zealand. Hey, Raina. Welcome to the stream. Hi from New Zealand. RDT says, what blew me away is that squirrels are omnivores. Read some crazy Reddit stories, so I had to Google it. Yeah. Well, I mean, they're rodents, so they'll eat anything, right? Just like another, like most rodents will. But yeah, so today I'm starting off the stream, for those of you who just joined us, I'm starting off the stream on the very important topic of whether there are squirrels in Europe, and also how popular Jaffa cakes are outside of like the UK. I'm just wondering if other countries eat Jaffa cakes. Raquina and Reina, we have the same name. Yeah. I know, it made me do a little bit of a double take when I saw the names. Yep, two different people. So yes, if any of the folks who've just joined us have any insight on either squirrels and or Jaffa cakes, please feel free to post in chat. We usually like to just kind of chat here for the first few minutes of the stream while we wait for folks to come on in, and then we'll get started with the real stuff. But I've been dying to ask this question about the Jaffa cakes because I got the orange ones. Raina says, New Zealand, the Jaffa cake is not popular. We have pavlova. Yes, yeah, pavlova is very good. I have had pavlova. Yep. And I also know about pavlova from the episode of Bluey where they make pavlova. Yeah. So it's apparent that it has some level of cultural significance if it has made it to Bluey. Great show, by the way. Thanks, New Zealand. Oh, and I forgot to update my MooBot command. We're actually on lesson 15 and 16. So let me fix that really quickly. Sorry about that. Let me just fix that. Okay, this should update by the next time it posts. All right, there we go. That's fixed. Alrighty, folks. Let's go ahead and get started. As always, if you're new to the stream, we have some first-time folks this time. It's awesome to have you here. Feel free to ask questions. That's what we're here for. And there's no such thing as a stupid question or a silly question. Hey, RatsQ, good to see you. Yeah, there's no such thing as a stupid question or a silly question. As long as it's related to the material, I'm happy to explain things again. I'm happy to, talk about something in more detail. It's all good. We're all learning together. And as always, we like to start these streams off on these Python streams anyway. With a review of what we covered last week. However, if you didn't join us last week, that's fine. We're going to do a quiz. Actually, we're going to do a couple quizzes today. We're going to do a couple quizzes today on the material we covered last week. But if you weren't here last week, that's fine. We do the questions together. And you're also welcome to make your best guess, or maybe you're coming in with some knowledge, that you already have about these topics, and that's fine too. It's a collaborative effort. It's not meant to be stressful. It's not meant to be a real test. It's just meant to see how well did we retain the information that we learned last week. Because the two best ways to really learn something, not just to learn about something, but to actually learn and absorb information, is repetition and application. Repetition and application are the two best ways to actually learn a topic. And so that's why we always start these streams off with a review of what we covered last time. And then only once we've actually done the review and essentially aced the quizzes, then do we go on to the new material. Yeah, exactly. As Celeste says, if you have a question, most times you are not the only one with that question. So help your friends out, be brave, and ask. Yes, exactly. And it's also fine to say, I don't know either. I will ask you all questions occasionally, sometimes to reinforce a topic, to review something we've already learned. And it's okay to say, hey, I don't know. Can you help me out? And I don't know is a valid answer too. No matter what they might have told you in school, I don't know is a valid answer. Or I think is a valid answer too, if you're not quite sure about something. All right. So with all that on the table, let's go ahead and get into the quizzes from the previous week. Oh, but before we do that, if you're watching this on YouTube in like 3 months or whenever I get around to posting it, hopefully sooner, if you're watching this on YouTube, please comment down below to my earlier questions about squirrels and Jaffa cakes. I do see when anybody posts a comment on my YouTube videos, I get a notification about it. So I will be watching for those. So please do comment down below whether or not squirrels are a thing in your country and whether Jaffa cakes are popular in your country. Thank you for this important public service. All right. So we did these exercises last week on XML and JSON because what we covered last week was using web services, mainly APIs. And so how do we use APIs to essentially retrieve information in XML and JSON format? And then how do we sort of work with that information in Python to extract insights and data out of that data structure, out of XML and or JSON. So let's go into the quiz first on XML. And I think, kind of the consensus last week was that, XML is less popular for web services and for, working with APIs. You're less likely to encounter XML. And it seemed like the consensus last week among chat was that, yes, some folks had never worked with XML before. It was just less known, less used. I work with XML in my day job, just in a piece of the software that we use, piece of software that we use that stores sort of structures in XML format. And so I've had to really dig into XML before to modify it and figure out what's going on. But I haven't actually ever encountered it in like a pure web format, I don't think. So it is kind of interesting. I think the far more popular format is JSON, but still, you never know when knowing about how to work with XML is going to come in handy to, your day job. So we're going to go ahead and do this quiz. And basically how it works is I just read out the question and then I read out the answers, and then chat, you make your best guesses, I make my best guess, and then that's what we go with. And it's also perfectly acceptable to go back and look at the material. This is not a closed book quiz, because being a real developer, being a real coder is knowing where to find the information that you need to get your work done. So if you can Google something, if you can go back into the material and read about it and find the answer, that's perfectly acceptable. This is an open book quiz, as they like to say in school. All right, here we go. What is serialization when we're talking about web services? Is it A, making it so that dictionaries can maintain keys in sorted order? B, the act of taking data stored in a stored in a program and formatting it so it can be sent across the network. C, sorting all the data stored in a tuple. Or D, marking each network packet so it can be put back into order on the receiving system. What do we think? A, B, C, D. What do we think, chat? Null says B. I think there's a few context clues that we can use in here to maybe kind of suss out the answer, even if we're not sure. Web2 Bruno, thank you so much for the follow. Good to have you here. Any other guesses, chat? What do we think? I think we can rule out maybe a couple of these, right? I think we could probably rule out C, right? We can probably rule out C. It's not really, when we're talking about serialization in the context of web services, I don't think this really applies. Also, same with A, making so the dictionaries, I don't really understand how that applies strictly to web services. So yeah, I would say Space says I'm torn between B and D. Yeah, potentially either of these could be, either of these could be a potential answer. Maybe they both have to do with web services, right? In this case, I think I'm probably gonna go with B. Just because we're talking strictly about XML here. And so what XML essentially is, it's just a way to kind of structure and format a data file. So it's less referring to like networking and more referring to, we have some data, we want it to have a strict structure, and we want to kind of make it have a strict hierarchy and a strict structure, kind of like HTML, right? HTML has a tree, it has a hierarchy, and XML is a really similar kind of formatting methodology. And so I think I'm going to go with B here, active taking data stored in a program and formatting it so it can be sent across the network. Yeah, I'm going to go with B here, I think. But again, if any of you at any point think that I am dead wrong, point it out and we'll talk about it. We'll look it up. We'll do research. We'll figure it out. So it's okay to say, hey, I think you're wrong. All right, number 2. What is the name of the Python library that we use to parse XML data? Is it xml.json, xml2, xml etree.elementtree, or xml miss? Hey, Killer Code, welcome. Good to have you here. What do we think? A, B, C, D. JS Maniac says C. Null Recall says C. What do we think, folks? Any other guesses? Yeah, I'm going to go with C. I don't think there's really any other options here because when we are parsing XML, we're essentially building a tree. Space says C as well. Yeah, we're essentially building an element tree. That's what we're doing. Similar to HTML, XML is formatted in kind of a tree hierarchy format where you have parent tags and child tags. And we're going to see, that this tree, oh, thank you so much for the bits. My goodness. What can you do with 8 bits? I have no idea, but thank you anyway. Very lovely of you. Thank you, Coder. Thank you, Code Writer. TV Josh says, I vote XML too. In this case, it is going to be element tree. I'm 99% sure, just because that's essentially what we're doing is we're taking that XML and we are telling Python that, hey, turn this into a hierarchy tree, and that helps Python understand the parent-child relationship so that we can drill down into those and get what we need out of the data. Ooh, here we have a potential multi-select question, it looks like. Which of the following are not commonly used serialization formats? Which of the following are not commonly used serialization formats? Okay, so keep in mind the not here. So out of these, which are not commonly used serialization formats? Well, I know which ones are, I think. I know which ones are commonly used, right? The 2 most common are XML and JSON, right? So I would think that, as Null says, maybe the first 3 are not. Does that seem reasonable? You know, these multiple select ones can be a little tricky, but I mean, these are the only two that we discussed in the material. So, you know, as far as serialization formats, so unless anybody has any arguments, I would think that these three are reasonable since we only talked about these two, with JSON being by far the more popular one. Okay, I don't see anybody telling me I'm, you know, being ridiculous here. So we'll go with that. Okay, what is the method to cause Python to parse XML that is stored in a string? What is the method to cause Python to parse XML that is stored in a string? Is it XPath, extract, from string, read all, or parse? This one's a little tough. Yeah, this one's a little tough. XPath, is it A, XPath, B, extract, C, from string, D, read all, or E, parse? We've got, let's see, you said 1, 2, 3, 4, 5. So we've got Runamucker saying maybe parse. Null Recall saying maybe C, from string. Any other guesses, chat? JS Maniac says parse. This one's a bit tricky, I think. Given what I remember from last week, I think this one might be trying to trick us a little bit. Because I think parse is a valid answer, but not for XML. I think parse is a valid answer, but not for XML. I think parse is valid, but for JSON. Now, I could be wrong here, but I think, yeah, so you're not wrong. Right, Spacey, I feel like parse is too easy. I think it's a correct answer, but not for XML. Adam Fighter, welcome to the stream. They say, XPath maybe? Yeah, I mean, that's a reasonable guess. Runwalker says, I think I'm getting it now. Okay, so we've got a few different answers here. We've got a few different competing answers. And I'm going to say, so I'll just put my sort of proposition out there. I think it's from string. But again, I could be wrong here too. So like I said, this is an open book quiz. So we're going to go back and we're going to look at the lesson and double check. We're going to double check what it actually should be. So, and this kind of helps answer the previous question too. It is element tree. That's the library we import to read XML. So that helps. And okay, so here's our data. And then here, yeah, so we're going to read that data into the element tree. We're actually going to say from string. Here. Yeah, so from string, let me just double check that. So that's JSON, yeah. So we're actually going to say element tree from string and then pass the input in that way. Yep. So in this case, the answer is going to be from string, although good reasoning on, saying, well, maybe XPath has to do with XML. It makes sense. And sometimes they'll sneak in, on this quiz, they'll sneak in answers that are like from other languages. So you might see an answer that's correct in JavaScript or another language, but isn't necessarily correct in Python. Yeah, so we're parsing a string and we're putting it into hey, Code Drift, good to see you. We're parsing the string and we're just putting it into an element tree, into a hierarchy, and then we're reading from that. JS says, right, my JSON let me down. Yeah, no, that's the confusing part, right? As you start to learn more languages, it can get really hard to remember the syntax across multiple languages. I've talked repeatedly about how, after learning SQL and Python and React and HTML, CSS, JavaScript, C#, all these, Visual Basic, all these different languages, that I cannot remember how to write comments in any particular language because I will get it wrong every time. I will use the wrong comment syntax and I have to Google it, even though it's the silliest thing in the world. So yeah, it totally makes sense. Hey, Get Alpine, good to see you. All right, next question. Killer Code says, my teacher wanted to eat me alive because I wanted to use goto in Python. Oh man, that's awesome. Real basic knowledge right there. Yeah, no, it happens, right? It happens. And a lot of times I'll be like, hey, I know that this is possible to do because I've done it in like JavaScript, right? But like I don't know the syntax to do it in Python. And yeah, so that happens a lot. C64 basic. That's awesome though, that you get to start on a Commodore 64. Hey, Juggernaut, thank you so much for the follow. Good to have you here. All right, in this XML, which are the complex elements? Which are the complex elements? So we have an XML here. It's got a sort of a master wrapper tag of people, and there are 2 person tags inside the people tag. And inside each person tag, we have a name tag and a phone tag. So out of those tags, out of people, person, name, and phone, which ones would you consider to be complex elements in this XML? And JS says, so all elements that contain other elements and or attributes. Yes, pretty much hit the nail on the head there with your definition. So yeah, I'm going to say people, and Null Recall says people in person. Get Alpine says people is the most complex. Yes, so definitely people, at minimum, people. But then also person has, 2 children inside of it. So I'm going to consider people and person to be complex. And yeah, Adam Fighter says, is it person? Complex sometimes means combined. Yeah, I think what they're asking here is, a complex element is going to contain additional tags. It's going to contain, additional elements of the hierarchy or additional nodes. I should stop saying tags. That's HTML. But nodes is going to contain additional nodes, whereas a simple tag is just going to be, or simple node, sorry, is just going to contain, it's kind of be an endpoint, right? It's going to be a stopping point, the lowest level of the hierarchy. So in this case, I'm going to say person and people, and we'll see if that's right. Complex meaning that it requires additional reading of nodes. Yeah, there's more to drill into inside of both people and person. That's kind of my interpretation. And so the converse of that then is in the same XML, which are the simple elements then? So, and I think we've kind of already answered that in our sort of discussion prior here. So given the logic that we're using here, I would say that name and phone are going to be the simple elements. Given that they are kind of endpoints in the hierarchy, you can't drill down any further from those. They just contain text. Yeah. We'll see if that interpretation is correct. I think either we are going to get both of these questions right or both of these questions wrong. Hey, Crayon, good to have you here. All right, in the following XML, which are attributes? Which are attributes? Now, I'll give you a clue here. If you know HTML, that's going to help you here. If you know HTML and what attributes are in HTML, you should know how to answer this question. All right, so in the following XML, which are attributes? Is it going to be email, name, hide, person, or type? And this is a multi-select question. We're on 200% quiz results. I don't know. I never guarantee it, right? What do we think? Which are attributes? Yeah, we got folks saying type and hide. Yep, I think I would agree with that. In this case, we have these elements, right? We have these nodes, XML nodes. And in 2 of them, we have some additional information that's not within the tag itself. It's within like kind of the open and close brackets of the element. So this is sort of giving some additional classification to the data that's contained within this element. So in this case, type is equal to international and hide is equal to yes. And so, yeah, those are attributes. And it's just the same as HTML, right? You do that all the time in HTML. You add additional attributes for styling or for behavior to a tag, and you can do the exact same thing in XML. Yes, as Adam Fighter said, an attribute is some quality that something bears, right? And so these are qualities of each of these elements. The phone has the quality of international, or the type of international, and email has the quality of hide. Hide equals yes. All right, so given our talk kind of about hierarchies, in the following XML, which node is the parent node of node E? Is it going to be B, C, E, or A? And I know this is confusing, so just say the letter that you think it is. Which node is the parent node of node E? Nondescript. I'm glad you're having fun. Good to have you here. Yay, this is fun. Yeah, I'm glad this is fun. That's the goal. It shouldn't be stressful. Quizzes shouldn't be stressful. They should be fun. So thank you for that. Yeah, we answer B, C. Yeah, I know. We got folks saying C. Jess Macadam, thank you so much for the follow. Good to have you here. Yeah, so if we look at node E here, we can see that it's nested inside of node C. So I would consider that to be the parent. Yes. Yep. All right. Looking at the following XML, what text value would we find at path A, C, E? So if we follow the path A, C, E, what text value would we find at that path? So you can just say what letter you think it is. It's going to be Z. Nondescript says it's going to be Z. JS Maniac says it's going to be Z. Killer Code says, I will never learn these parent-child stuff. It's really just kind of following the path, right? You can kind of think of it like a tree. And so if you follow up the trunk, you're going to hit a branch, which is then going to have other branches coming off of it. And so you just it's a path that you can trace down. It's basically like a decision tree or a logic tree, or even like one of those choose your own adventure books, where at each point you have an option of multiple paths to take. And so then you just follow the path. Yeah, so let's go ahead and follow the path, and maybe that'll help with some of those parent-child relationships. Yeah, so let's follow the path. So we start with A, and we can see that A is kind of the overall wrapper, so that really doesn't, narrow it down at all. But the next item in the path is C. So we start with A, and then we head to C, and we can see that C captures this entire sort of area of the XML. So C encloses this area of the XML. So from within C, we need to go to one of its children. And in this case, they've specified they want us to go to child E. So if we go from parent to child E, then we can see that the value at node E is actually Z. Of course, Killer Code. I'm glad that was helpful. Yeah. Yep. It's just nested boxes, or, some people like to think of it like a tree. Some people like to think of it like a path, or boxes containing, like nesting boxes, like those Matryoshka dolls that, you open one up and it contains more dolls inside of it, that type of thing. It's really just a way to set a hierarchy of data, and a way to define data relationships. Yeah, or like File Explorer. That's a great analogy for it. It's just like File Explorer, where you can open up a folder, and then it could have files and or multiple folders within it. And then so you drill down into that folder and the next and the next. And you can go down multiple levels, getting more and more specific each time, but it forms a hierarchy of data. Yeah. All right, but it is going to be Z in this case. Okay, what is the purpose of XML schema? So why do we have an XML schema? Is it to compute checksums on data to make sure it's not modified in transit? A. B, to transfer XML data reliably during network outages. C, a Python program to transform XML files. Or D, to establish a contract as to what is valid XML. So what is the purpose of an XML schema? This one's a little bit harder, but I believe at the top of most XML files, you will see kind of a schema definition of what type of XML is being generated in this file. And so what do we think the purpose of that schema is? We got a couple folks saying D here. And schema is kind of a tricky word, especially if you're not an English speaker. But yeah, schema is kind of like a blueprint. It kind of says like, hey, this is kind of the the structure of the data that's going to be expected here. And yeah, and I would agree with what folks are saying. I would agree with what folks are saying here in terms of it being D. Essentially, it's saying, hey, to the recipient, this is kind of the blueprint that we're following to build this XML. And so if it doesn't match this blueprint, then, you know, something in here is invalid. And so, yeah, I think I would agree with D, to establish a contract as to what is valid XML. Yeah. So if we were building a schema and we wanted to limit the values allowed in a string field to only those in a particular list, what XML tag would you use in your schema definition? Oh, this one's a bit tricky. So just to rephrase that. So we're building out that blueprint for our XML. We're defining what is valid XML. And we want to limit the values in a particular string field to only those in a particular list. What tag would we use in our definition? Is it going to be element, A, element, B, complex type, C, enumeration, D, sequence, or E, max occurs? What do we think? If you're familiar with other programming languages and like some of that vocabulary, you might be able to kind of at least make an educated guess on this one. Yeah, we got a few different guesses here. B, C. JS says, my knowledge of jargon is not working. No, that's fine. It's okay to guess. Moshko says 1. Element. Pedro says A, maybe. So yeah, we got a few different answers here, and that's fine. There's nothing wrong with that. This one was a hard one. I vote A. Yeah, so I think the keyword that kind of stands out to me here is in a particular list. And in other programming languages, I'm familiar with the concepts of enums or enumerations. And essentially what that means is that you have a limited list of values that can exist in that particular field. So it could be enumeration, because I mean, that's a word I'm familiar with that fits the definition of what we're trying to do here. I think it could be D, sequence as well, because that fits a similar definition, right? It's a set series of values. So both of these kind of mean a set predefined series of values. Yeah. So I'm thinking, and the reason I'm not thinking it's element, is that essentially element is more of just a general definition of like a node or a thing. It's like I would consider like this to be an element or this to be an element. Just anything that any set of tags that has something in it that exists in the XML file. So I would consider this to be too broad. But I'm thinking it's probably one of these, and I'm not sure which. So let's look that up really quickly. Let's see if we can figure that out. So let's see. I don't think the text actually spends very long on. Yeah, the text doesn't spend all that long on XML actually. So let's just Google it really quickly. Oh, thank you for the stretch and the posture check and the hydrate. Okay. Did I hydrate for you there? Straighten up a little bit and posture check. I needed that. My shoulder has not been my friend lately, so I've started doing Pilates and it's kicking my butt, which in a good way. Yeah, Pilates is brutal. But I feel like I got to keep up with the retired ladies in the class who go, 5 times a week. They're beasts, I tell you what. Okay, so I'm pulling up a incognito meter. I'm pulling a incognito window up here so we can Google it. And I'm going to say, oh, hey, Ultimate Tacos. Good to have you here. Came in late. What are we looking at? Documentation. We're doing a quiz. We're doing a quiz to test our knowledge of working with XML in Python. And the question we are working on is this one right here, question 11. So if we're building a schema and we want to limit the values allowed in a string field to only those in a particular list, what XML tag would we use in our schema definition? And we're thinking it's between either enumeration or sequence, and we're just trying to find that out. So I'm going to do a quick Google here, and then I'll pull it over onto this screen. XML schema, list of values? I don't know. Let's see. Oh, so that's a list element. So that's not quite what we want, but let's see if we can find it in here. Oh, no, you're fine, Ultimate Tacos. It's all good. Please stick around because it's not it's perfectly fine if you weren't here last week. We're just kind of figuring these things out together. Hey, Matthias, good to have you here. Welcome, folks. All right. Syntax elements. Let's see. Let's do this. We'll say, I'm just going to Google enumerate, like, what is, is it this one? I'm just gonna search for that. See if that even comes up as an option. Yeah, question's a little wonky, and that's okay. It's okay for questions to be a little wonky sometimes. Okay, so it's a restriction. Restriction on a series of values. So the base value is a string. So we can set a pattern. Other restrictions on series of values. White space, length. Okay, so enumeration defines a list. Okay, here we go. Enumeration defines a list of acceptable values. So that could be, that's looking good. And I'm also going to search for sequence. Yeah, and I'll go back up in a second. I'll leave this tab open. We'll just duplicate this tab, and then we'll search for this as well. Sequence element. The sequence element specifies that the child elements must appear in a sequence. Okay. Ultimate Taco says, was there a specific reason you decided to pull up an incognito window to research the question? I just don't want you all to see all my my recent search history while I'm typing in the Google window. That's literally it. There's nothing spicy about it or anything. That's not something I want you to see. Y'all don't need to see that. How to dispose of evidence, right? Yeah. Okay, so this also looks like it still could be a valid answer. So sequence as well. First name, last name. So limit the values to only those in a particular list. I mean, that seems valid too. City, country. All right, let's go back to the other one. Enumeration also defines a list of acceptable values. Restrictions on a series of values. I don't want to spend too much time on this question because I don't think it's worth it. But I am curious. Okay, here we go. Restrictions on a set of values. We could use the enumeration constraint. Yeah. Okay. So what's the difference here between enumeration and sequence? It's a sequence tag there. Would you use? So I'm feeling like these are doing the same thing. Maybe I'm misunderstanding. Yeah, I'm leaning towards enumeration. I know, right? Hey, W3 schools works. I mean, I know that there's yeah, and sequence specifies order, right? Yeah. So, and this doesn't say anything about order. So I'm going to go with enumeration. That might be wrong, but I think I'm justified in this choice. So I'm honestly not going to be mad if this is marked wrong because like I feel like this is a valid choice. Yeah, no, I honestly like W3 schools. I know that Leon doesn't like it, but I mean, it's good sometimes. Yeah. We'll go with C. Could be wrong, but I'm not going to be mad if it is. All right. For this XML schema, and this XML, which tag is incorrect? So we need to look at both. So we need to look at the schema. Ooh, okay, hang on. Just sorry, pause. This one is explicitly using a sequence here. So I'm feeling like they might want us to pick sequence in this question. Anyway, I don't know. We'll leave it for now. All right, which tag is incorrect? So complex type, we got name, person, defining a sequence. Then we've got elements of last name with a type of string, age with a type of integer, and date born with a type of date. So looking at this XML and comparing it against the schema, which tag do we think is incorrect? So I'm seeing person, that looks fine. Last name looks fine. Age is an integer, but yeah, the first thing that caught my eye was that this tag is capitalized, which, I mean, you do that for React, but it's not common to see elsewhere, like outside of React. So I would consider that, yeah, this could be incorrect. And then if we look here at the schema, the name, yeah, so the tag name is incorrect because this one is lowercase and this one is capitalized. Yeah. Taco says Python is so syntactically simple compared to JavaScript. Yeah, I would say in general it's more English-like in the way it's written. Yeah, and that's what makes it a great first language for a lot of people. A lot of people start with Python and then graduate to additional languages on top of it. But I really like it so far. Okay, and then this question here, I don't think this was something that was explicitly covered in the reading material. Sometimes they put in questions from like the videos or other things that we didn't cover. But what does the Z mean in this representation of time? And you've probably actually seen time formatted like this before, coming from various systems. What does the Z mean here? We've got a date. We've got day, year, month, day, and then a time value of 9:30:10, and then a Z. Zulu. Yeah. Is it A, the hours value is in the range 0 to 12, B, this time is in the UTC time zone, C, the local time zone for this time is in New Zealand. Yay, New Zealand. We were just talking about that. R3 Duchess, thank you for the follow. Good to have you here. Or D, this time is daylight savings time. Matthias says, I did Z time today, planning the social anxiety meetups. Zealand, yeah. Looks like the time that my router shows. Yeah, I'm kind of guessing here, but I'm thinking it's B. I'm thinking that the Z is to show that we are in UTC time. But we can Google this one as well. Because again, this wasn't in the written material, at least my recollection. What does the Z in timestamp mean? Yeah. Yeah, it's UTC. Offset from, yeah, okay, so it's offset by 0 from Coordinated Universal Time, or UTC. Yep, so it means it's in UTC time zone. Yay, all right. Google the rescue. Honestly, I learned something because I didn't really, like, a lot of the servers and, software and stuff that I work with at work, uses this time format, or it will format things in this format, and then we have to convert it to Eastern, or, other time zones depending on what we're working with. And so, yeah, it's good to know that the Z just means 0 offset. Hey, Debdy, good to have you here. Ultimate says, see, I didn't study. No, that's fine. It's all good. We're learning things together. Yep. All right, almost done with the quiz, folks. What is a good time zone to use when computers are exchanging data over APIs? A, universal time, B, the local time zone of the sending computer without daylight savings time, C, the local time zone of the sending computer, or D, the local time zone of the receiving computer? Yeah, I think the answer here is pretty self-explanatory. It should be A, universal time GMT. Yeah. Like I mentioned, all the servers and software that I work with at work, uses UTC. Just because you never know if you never know what time zone the host computer is or your computer is, and it's better if you don't have to translate. You can always do the translation locally on your end, and just as long as you know you're offset from UTC. Yeah. Alrighty, last one here. Which of the following dates is in ISO 8601 format? Is it A, B, C, or D? This one should be pretty, based on the previous questions, this one should be a pretty educated guess. What do we think, folks? Free Palestine says C. Killer Code says last one. Null Recall says B. R3 says most likely B. Yeah, I'm going to go with B here. Yep. I'm going to go with B. Yeah, because this is the, so ISO 8601 is essentially the, that's like the standard UTC way to format time. It's essentially this, this same format up here. Yep. All right. Last thing I want to do here is just, this question is really bugging me. I feel like, I think I'm going to change, even though as much as I want this to be enumeration, I feel like since they used the sequence tag in this very next question, I think I'm going to make a knee-jerk decision here and change it to sequence, even though I don't agree with it. But we'll see. That could be a rookie mistake. I don't know. Let's see you can place your bets, chat, on whether that was a bad decision or not. But all right, let's submit it. Noel says, I'm standing on enumeration. Yeah, I know. Just the fact that they used sequence in the very next question is killing me. So, all right, let's submit. Hey, all right, so we missed one. That was probably the one that I changed. Yeah, all right. I shouldn't have changed it. It was right. I shouldn't have changed it. It was enumeration. I was right the entire time. But I let my nerves get the better of me there. Second try. Yeah. No, it's all good. So we have to wait a couple minutes before we can take it again. But essentially, I'm feeling, like we know all the answers this time, especially this one here. So it'll be a quick fix to get it 100% the second time. Yeah, exactly. I know. Crayon says always that one question where you think and think and think and then decide to switch and it never works out. Yep. I'm very guilty of overthinking that. All right. However, we have a little bit of time, so we have to wait 10 minutes for this quiz to reset, but that's okay because we have another quiz to do. So this one shouldn't take too terribly long. I think we're going to have to do maybe some Googling here based on the first question. So real quick chat, somebody Google. Who is credited with getting the JSON movement started? Because again, this stuff wasn't in the material. I think that's probably in the videos. Is it Crockford? Okay, great. What about REST? Who's fastest on that Google? Who's fastest on their Google game? Hey, Gian Lumele, thank you so much for being here. Welcome. Roy Fielding. All right, great. Now we should know this one. What Python library do we have to import to parse and handle JSON? And so this was the question that almost tripped a few of us up on the other quiz, right? Seeing that word parse. Is it going to be RE, Beautiful Soup, Element Tree, or JSON? Which library do you use to handle JSON? What do we think, chat? We can narrow it down a little bit. Yeah, not the first two, right? And what do we use this one for, chat? What is Element Tree used for? Yeah, Beautiful Soup was for HTML scraping, so it's not that. It's also not this one. I don't even know what that one is. What do we use Element Tree for, chat? I'll give you a hint. We just oh, that's right. It is regex. Yeah. Yeah, we use it for XML, right? So the only remaining option is this one here, and that is definitely the answer. All right. Which of the following is true about? Damn, you guys are good. Hey, that's what repetition does for you, right? We've repeated this stuff a few times now, and so we're kind of getting the hang of it a little bit. Samuel, thank you so much for the follow. Which of the following is true about an API? Does it define the header bits in the first 8 bits of all IP packets? Is it a contract that defines how to use a software library? Does it keep servers running even when the power is off? Or does it define the pinouts for USB connectors? What do we think, chat? A, B, C, or D? Duchess says B. Null says B. CodeWriter says last one. I'm thinking we can actually probably rule out these last two, right? I don't even know what this one is trying to say. 3 would be nice, right? Yeah. This one here, no. It has nothing to do with USB, right? So I think it's going to be either A or B. And of those two, I think conceptually B is the best answer here. It's essentially saying, so an API is kind of like a gatekeeper for the data that you're trying to access stored on somebody else's server in a different location. It defines who is allowed to access that data. It defines what the structure of the data is. It defines what the structure of your request should be, right? It defines how often you're allowed to access the data. It defines, everything about like how you're able to interact with that data. Yeah. Yeah. Yeah, I think you're right. It's trying to confuse it with what do they call it? One of those external power sources. Yeah, it's got a similar name and I can't think of it right now. All right. What is the UPS? That's right. Yeah. UPS. Yeah, I get it. Yep. Yes, it's an interface, and interfaces are contracts. Yeah, exactly right. That's a great way to define it, Duchess. It's an interface, and interfaces are contracts. Yeah. Yeah, UPS. I worked at a job one time where I had this giant UPS sitting next to my desk at all times. And I always thought like, man, like what if this thing catches on fire or something? So I just had this giant like file cabinet sized UPS next to my desk. Anyway, what is the method used to parse a string containing JSON data so that you can work with the data in Python? Now, y'all should know this answer because we've talked about it a couple times as not the answer for some of the other questions we've looked at. Is it going to be connect, parse, loads, or read? Null says loads. Any other guesses? What do we think, chat? Duchess says, I'm new to Python. I think B. Okay, so we've got B and C maybe. Any other guesses? And it's okay to just throw a guess out there too if you're not sure. Just whatever looks logical. Sandy says C. Matthias says 4. Clipped says S is for string in JSON. Load S. Okay. And I'm actually going to look at this one, not because I doubt you guys' answers, just because I was remembering it as parse. So I need to refresh myself here. So we're going to go down here. Okay, yes, it is loads. And that's a good, I'm glad that I looked at that because I was remembering it as json.parse just because I was thinking about parsing JSON. Yeah, so load file and specifically load a string. Yeah. So XML uses from string and JSON uses load S. Makes sense. I will have to remember that. But I'm glad we reviewed it because I was misremembering. So again, that's why we do this, right? That's why we do repetition and application of what we're learning, because otherwise you could end up with something, stored long-term in your brain that's incorrect. And then once something is stored incorrectly in your long-term memory, it's a lot harder to change it than if it's corrected before it gets to your long-term memory, right? Once you start to sort of ingrain a belief or an idea in your head, it takes multiple repetitions of the right thing before you can actually get it out of there. So hopefully I'm able to change this little mental memory before it gets ingrained. But yes, JSON load S. Okay. All right. Which of the following is a web services approach used by the Twitter API? Matthias says, oof, you speak like my Yankee. Hey, I mean, I wouldn't be saying it if it didn't work, right? All right. So this is one that this is not in the material, but if you had to guess, and this is a little bit just me playing inside baseball here, knowing a little bit about APIs, but I would say, just kind of making an educated guess here, I'm going to say REST. Does anybody disagree with that? Just because REST APIs are the most common, kind of the modern API format. So I would assume that Twitter or X or whatever it's called now is going to use REST API format. Yeah, folks are saying they agree. Okay, we'll go with that. And, I would assume they're not trying to curveball me here. Yeah. Thank you so much for the follow, Ritesh. Good to have you here. Yeah. It's yeah, everybody speaking of which, everybody follow me on Blue Sky, please. If you're currently following me on Twitter or X, please follow me on Blue Sky instead. Hey Ritesh, good to have you here. You can I'm just Mayan Wolf on Blue Sky. That's where I am. Give me a follow. That's where I'm migrating to. So eventually you won't be able to, get updates from me on Twitter at all. I'm going to be off Twitter at some point. I don't know exactly when, but at some point I will be moving off Twitter and onto Blue Sky. So if you want to keep following me, please give me a follow on Blue Sky. Anyway, what type of variable will you get in Python when the following JSON is parsed? So this JSON here, what will it be converted to in Python when the following JSON is parsed? Is it going to be 3 tuples, 1 tuple, a dictionary with 1 key value pair, a list with 3 items, or a dictionary with 3 key value pairs? What is this going to turn into when the JSON, what is it going to turn into in Python when the JSON is parsed? And this is not a trick question either. If you're trying to see how it's a trick question, it's not a trick question. Just what is this going to be in Python? Yeah, folks are saying D, a list with 3 items. Yeah, and I would agree with that. Essentially, if you recall from the beautiful list, yes. If you remember from the material, it's basically like JSON is pretty much a native format, right? It's a Python native format. You really don't have to do very much to convert these items from JSON to Python because these are all structures that Python understands. They are all structures that are already native to Python. Yeah. So it's going to be essentially just be a list with 3 items. And similarly here, if we take this JSON, what is it going to turn into? Is it going to turn into a list of tuples, a dictionary, a list with 6 items, a list with 3 items, or a tuple with 3 items? Yeah, folks are saying B, a dictionary with 3 key value pairs. And yeah, I would agree with that. It's going to just be a dictionary with 3 key value pairs because essentially in JSON, it's just an object with key value pairs. And in Python, if we just convert that to Python vocabulary, it's going to be a dictionary with 3 key value pairs. Again, these structures are native to Python, so you can, and they're native to a lot of languages too. You can, they are. That's why JSON is such a common format for APIs, because no matter what language you're using to interact with that API, you're probably going to be able to parse the response from JSON. Yeah. All right, which of the following is not true about the service-oriented approach? And and we're talking to this about software as a service, APIs as a service, etc. Standards are developed where many pairs of applications must work together, A, and remember, we're looking at not true here, so it's not true. B, an application makes use of the services provided by other applications. C, an application runs together all in one place. Or D, web services and APIs are used to transfer data between applications. Which of these is not true? And if you've ever interacted with an API ever, the answer should be fairly apparent. So even if you don't know Python, if you've ever interacted with an API for any reason, the answer should hopefully be somewhat apparent. Ritesh says Blue Sky is not available. Yeah, and I know it's not available in all countries. That's why I'm still on Twitter. You can follow me on Twitter if you would like at MayanWolf. So same name as my Twitch name here. You can still follow me on Twitter if you would like. Yeah, exactly. I'm going to say C as well, right? Because what modern application actually runs everything all together in one place anymore, right? Pretty much every single application that you run is going to be contacting external services either for storage or for functionality, for packages, for, you're gonna generally be with whatever service you use, you're gonna be contacting additional services for components or functionality that are vital to that service. Cake says me sweating bullets in the corner. All right, almost done with this one, folks. If the following JSON were parsed and put into the variable X, what Python code would extract Leah Culver from the JSON? Now, you should be able to do this one even if you only know JavaScript. You should be able to follow this one because the methodology for getting to this information is exactly the same in Python as it is in JavaScript. So let's walk through this one together and see if we can figure out how to get to the value of Leah Culver from this JSON. So JSON is in the variable X, so we're going to start with X. And if we want to get to Leah Culver, we can see that actually it's down here, name Leah Culver. So let's walk this back. So we can see that Leah Culver is inside of the key value pair of users. And what is the element that is attached to this key? What is the value of this key? What data type is it, chat? What data type is the element that is inside of this key? It's an array or a list, as we would call it in Python. Yeah, it's an array in JavaScript and it's a list in Python. Okay, so looking at this as a list, we can see that this first list value sort of encapsulates everything that's inside this child object, right? Or this child dictionary. So this is all within the first element of the list. So in a list or an array, how do we access the first element of that list or that array? Especially here, since we can see that, since it's a list, it doesn't have a key value, so we can't access a key value directly. We have to use the index value. Yes. Yeah, so it's going to be the 0th index. And so we can see that the answer, we can see that the answer is actually probably going to be D here. So X users 0, but let's confirm that, right? So we're inside users, we're inside the 0th index, and then from there, once we go in here, we can see that the first key is status, the next one is location, followed by screen name, and then followed by name. So we can access the name Leah Culver by going to users, the 0th element of this list, and then the name element in this dictionary. Yep. Yeah. So it should be D here. Yeah, you were right. Exactly. And it's the same principle as if you were doing this in JavaScript, which is nice, right? And we kind of talked about this next one before, I think. Which of these two web service approaches is preferred in most modern service-oriented applications? Is it going to be SOAP or REST? Yeah, it's going to be REST. Oh, look, the answer to a previous question. Yeah, right? REST. Okay. What library call do you make to append properly encoded parameters to the end of a URL like the following? So here we can see that, we've got some encoding at the end of this URL after the question mark. These are kind of properties, right? Or parameters that we can add into our URL. So is it going to be URL cat, parse URL encode, match, or encode? So these two are regex, and these two are URL lib. And I actually don't know the answer to this one. I'm thinking it, I'm just, knee jerk, I'm thinking maybe URL encode, but I'm not entirely sure. Yeah, that's kind of what I was thinking. Since this is strictly a URL, I'm thinking B. Yeah. Let's take a quick peek here at the material. I don't know if it's in here or not, or if it's one of those things that was in the videos. I don't remember it being in the, yeah, I would say B as well. Yeah, well, let's just go with B. URL encode is, yeah, one thing Python can do. Yeah, it can do that. Yep. Yeah, we'll go with that. Next one, what happens when you exceed the Google geocoding API rate limit? Is it going to perform very slowly? Probably not. You can't use the API until you respond to an email. Your application starts to perform very slowly, or you cannot use the API for 24 hours. Now, I'm guessing on this one, but given my experience with other APIs that have rate limiters, I'm going to say D on this one. What do we think, chat? Yeah. You still want it to be B, but I'm going to guess D. Yeah. Right? Yeah, I'm thinking D as well. Given that, I've worked with many other APIs that have rate limiters, and if you hit that rate limit, they're going to cut you off. It's not going to you're not going to cause any performance issues because it's Google, right? You're not going to crash Google with your dinky little project. But what you are going to do is they're going to cut you off like somebody who's had too many drinks at the bar, right? They're just going to cut you straight off. They're going to be like, try again in 24 hours. Yeah. What protocol does Twitter use to protect its API? And I actually do know this one, and it's only because I've messed a little bit with the before Twitter, imploded. I messed with the API a little bit, and it's going to be OAuth. Again, this wasn't in the material. This is one of those that was probably somewhere else in the videos or something like that. There's been a lot of questions like that lately. I'm not a huge fan, but in this case, it is OAuth. And OAuth is kind of the standard for modern authentication. And so that's why I would say that. All right. Last question. What header does Twitter use to tell you how many more API requests you can make before you will be rate limited? Again, this one was not in the material. We're going to have to kind of guess here. A, remaining. Yeah, that's what I would say too, is X, rate limit remaining, B, content type, C, X max requests, or D, request countdown. Yeah, I would say A. Everybody's saying A. I would agree with that. Yep, we'll go with that. Okay, folks, let's see how we did. I know we kind of blew through that a little quickly, but we had 2 quizzes this time, and 2 quizzes is a lot, especially since they both had more questions than normal. So we kind of went a little quicker than we might otherwise do. So we'll let you go ahead and see how we did on this one. Yay, we did it, chat. Good job. All right, so what we're going to do now, we got 100%, chat. Good job. We're going to go back to the first one. We're going to blow through it. We're going to get all the right answers. And then we're going to take a break. So we're going to 100% ace both of these quizzes. Yay, repassed. Yeah. We're going to 100% ace both of these quizzes. And then we're going to take our well-deserved break. Okay. So let's say done on this first quiz, and we're going to go back and we're just going to redo it real quick. Hey, Piano, good to have you here. So Piano, what we're doing right now is we just finished taking 2 quizzes, and we're going back and we are just really quickly blowing through the first one now that we know, what the answers are. So the reason I'm going so quickly through this is just because we've already done it once. So don't worry. Normally we spend a lot more time on each question. All right. Serialization is formatting data. Python library to parse XML data is this one. Not commonly used serialization, these 3. Parsing Python data from a string is from string. And chat, you had to watch 15 minutes of ads? Really? That's insane. I'm afraid I wish I had control over the number of ads that get shown on my stream, and unfortunately I don't. I've turned it as far down as I can. I know. I've minimized the amount of ads that you all are shown as much as I physically can on Twitch. Unfortunately, I have no way to shut them off. Yeah, I know, that's nuts. So if I get any of these questions wrong, chat, as I'm going through this, please stop me. All right, in XML, complex elements are person and people. Simple elements are name and phone. Attributes are type and hide. Parent node of node E is node C. Where would we find the path ACE? ACE, that's Z. Purpose of XML schema is to contract. Enumeration, this is the question that I made the silly mistake of changing my answer at the last minute and got it wrong. XML schema tag is correct, incorrect is age. Z means UTC. Universal time for exchanging data, and that's the ISO format. Okay. Tree. Okay, let's check these. So piano, what I will suggest for you, I can't make anyone gift you a sub, but what I will suggest is that if you want to watch my content and the ads are just way too much and I sympathize with you, I do move these over to YouTube, and my YouTube channel is ad free. You can watch all of my past content on YouTube ad free right now. And RDT just put a link to the YouTube channel there in chat. So that's ad free, and you don't have to worry. You can just watch all of that uninterrupted on my YouTube channel right now. I don't monetize my YouTube at all because YouTube, fortunately, at least as of now, lets you turn off ads. So hopefully that's helpful to you. Yeah, no worries, piano. And I did that on purpose for people like you who, for some reason, some people live in a particular area where they get just a ton of ads. And so that's why, my YouTube channel is not monetized and you can watch it there. Now it is time delayed, so you won't get the the most up-to-date videos, but I do move stuff over there regularly, and you have 2 years of backlog content. If you have 2 years of a backlog to get through on YouTube. So then I'm afraid that it must be on your end there, piano, because my YouTube channel is not monetized, so I get no money from that channel. So maybe you've got an extension installed or a virus or something, because yeah, I've got nothing switched on. Yeah. So I would maybe do a virus scan on your computer. All right, looks good. Let's go ahead and submit this and get our perfect score, and then we'll take a break. All right, we got it, folks. 100%. Done. All right. Good job, chat. We did it. So now if I look at the gradebook, we should see, oh, no, that's wrong. Yeah, we should see. Yay, all right, good. So I just wanted to make sure it recorded our 100% score there. Yeah, 100%. Let's go. All right, we're going to take a break, like I said. When we come back, we are going to blow through object-oriented programming. We're not going to spend a ton of time on this because what I really want to get to is the good stuff, chat. The good stuff, which is databases. My beloved SQL relational databases. The thing I work with every day. I don't work with object-oriented programming every day, so I'm going to selfishly maybe breeze through that a little bit. But we're going to give it its due time, but maybe not as much time as we might spend on some other things. So we're going to breeze through this. We're going to get to databases today, and we're going to have a little bit of fun with SQL. So if you've never used SQL before and you've been wanting to learn a little bit about it, then this is the place to be. So please stick around for that. But for now, we're going to take 5 minutes. Please go hydrate, use the restroom, whatever you got to do. And then when we come back, we're going to cover object-oriented programming, followed by databases. Matthias says, looking forward to SQL scares me. It shouldn't scare you. SQL is it's sort of like Python in that it's very approachable. So the basics, you can do a lot of really complex stuff with it, but the basics are really approachable. And so as long as you're not becoming like a SQL developer, the basics are going to be just fine for you. That's all you'll ever need to know. And so that's what we're going to cover. Right? Alrighty, 5 minutes, folks. See y'all shortly. Alrighty, folks, we got about a minute left in the break, so please come on back if you're coming back. Please make sure you're staying hydrated. If you've been sitting this entire time, please get up and stretch if you're able to. And as always, please pet your dogs, pet your cats, pet your significant other with their permission, of course, and then come on back. Alrighty, welcome back, everyone. I hope you had a good break. Uh, Kate Kuhn says, the only thing you need to remember with SQL is transactions. If you're ever doing something kind of risky, do it as a transaction. Yeah, we'll talk about that in a little bit, definitely, once we get to SQL. Killer Code says, when Tom Scott rewrote everything as content. Oh my goodness. That is one of my favorite videos of all time. I absolutely love it. Yeah, and someone is welcome to link that in chat if you would like to. But yeah, Tom Scott, content creator Tom Scott, is also a developer, and one point in one of his first jobs, he accidentally overwrote every record in a production database with the word content. And so that's a very easy thing to do with SQL. SQL is kind of one of those with great power comes great responsibility type languages, because it's very easy to break stuff if you don't know what you're doing. So yeah, that's one of my favorite videos of all time just because of that. Yeah, I almost did something similar to what you said there, Kate Kuhn. I say almost because I caught the transaction in time that I was able to roll it back before it was committed. So yeah, because it was such a massive transaction, it was going to be overwriting multiple millions of rows. And so the transaction was taking a long time to sort of compile. And so I was able to roll it back in process before it actually did any damage. Right. Yeah, I forgot a where clause. Exactly. That was it. And we'll talk for everybody who's like, what? I don't understand what you're talking about. We will get there, I promise. All right, but first we got to quickly cover object-oriented programming. Some of you might be familiar with object-oriented programming. It really depends on your background, right? Some folks start out in object-oriented languages, or object-oriented programming languages. It just really depends on your starting point for programming. But it helps us maintain larger programs. So we can use sequential code, conditional code, repetitive code, or functions to construct programs. We can use data structures like lists, tuples, and dictionaries. And then we design these data structures and write code to manipulate them. There are many ways to write programs, and by now you've probably written some programs that are not so elegant. Lord knows I have. And other programs that are more elegant. Even though your programs may be small, you're starting to see how there's a bit of an art and an aesthetic to writing code. As programs get to be millions of miles long, it becomes increasingly important to write code that is easy to understand. Please don't use single letter variable names, I beg you. If you're working on a million-line program, you can never keep the entire program in your mind at the same time. We need ways to break large programs into multiple smaller pieces so that we have less to look at when solving a problem, fixing a bug, or adding a new feature. In a way, object-oriented programming is a way to arrange your code so that you can zoom into 50 lines of the code and understand it while ignoring all the other lines of code for the moment. Killer Code says team spaghetti code. Yeah, what methodology you use is going to depend on, readability, on the length of the code. It's going to depend on team standards and cultures and practices, but there are some general kind of guidelines that we can follow, right? One of those is object-oriented programming. So we should learn the concepts of OOP before you can use them effectively. You should approach this chapter as a way to learn some terms and concepts and work through a few simple examples to lay a foundation for future learning. The key outcome of this chapter is to have a basic understanding of how objects are constructed, how they function, and more importantly, how we make use of the capabilities of objects that are provided to us by Python and Python libraries. All right, so what are objects? We've been using objects all along in this book. Python provides us with many built-in objects. Here's some simple code where the first few lines should feel very simple and natural to you. So we declare an empty list, we do some appends, we do a sort, we do a print of the first item in the list, we get a specific item in the list, and then we print that if it exists. So what is actually happening here? The first line constructs an object of type list. The second and third lines call the append method. The fourth line calls the sort method. And the fifth line retrieves the item at position 0. So some of those terms are going to be familiar, especially if you've used JavaScript before, right? We've all seen JavaScript methods, and we all kind of have a general understanding of what those are, right? They are sort of elements of a larger group that we can access. Sixth line calls the getItem method, and the seventh line is doing essentially the similar thing and calling getItem again. In this code, we call the getItem method in the list class and pass the list and the item we want retrieved from the list as parameters. So all of these methods, append, sort, these are all ways that we can interact with lists, right? And not every method is going to work on every data type, right? You can't do everything with a string that you can do with a list, and you can't do everything with a list that you can do with a string. Some methods work across multiple types, but some don't, right? Some methods are limited in the ways that you can interact with them. Thank you so much for the following, Dagraw. So we can take a look at the capabilities of an object by looking at the output of the dir function. So if we say, all right, stuff is a list, and what can I do? What are all the different ways that I can interact with that list? And if I call dir on this list item, then it will give me all the methods that I can use to interact with it. So again, very similar to JavaScript, right? We've kind of seen the similar thing before, in that in the same way in JavaScript, you can interact with a string in very specific ways. Or you can interact with an array in very specific ways, call very specific methods. So all those methods are contained within this list object. Yeah, essentially, what are you, right? What are you and how can I interact with you? So a program in its most basic form takes an input, does some processing, and produces an output. So in this case, we take an input and we convert that input to an integer, we subtract 1, and then we print whatever the non-US floor number is. So if we think more about this program, there is the outside world and the program. The input and the output aspects are where the program interacts with the outside world. Within the program, we have code and data to accomplish the task the program is designed to solve. One way to think about object-oriented programming is that it separates our program into multiple zones. Each zone contains some code and data and has well-defined interactions with the outside world and the other zones within the program. So looking back at this piece of code that we wrote previously, we were extracting a link using Beautiful Soup. So we're linking various aspects of the program together to accomplish a task. We read the URL into a string and then pass that to retrieve the data from the web. The URL library uses the socket library to make the actual network connection and retrieve the data. We take the string that URL lib returns and hand it to Beautiful Soup for parsing. So we're just handing this data back and forth to different elements of these methods and objects. We're passing that football back and forth as many times as we need to, until we get the information that we can output to the user. Beautiful Soup makes use of the object HTML parser and returns an object. We call the tags method on the returned object, and that returns a dictionary of tag objects. We loop through the tags and then call the get method for each tag to print out the href attribute. So essentially, taking this program, we can see this diagram here is going to tell us how each of those elements interact to take an input, do stuff to it, and then generate an output. So the program is essentially a network of objects. How do we build a network of interacting objects and orchestrate the movement of information between the objects to create a program? Again, this might be a little bit of a review if you are familiar with JavaScript already. But again, it's a concept that applies to multiple programming languages. It's also important to note that when you looked at the program several chapters back, you could understand what was going on in the program without even realizing that the program was orchestrating the movement of data between objects. It was just lines of code that got the job done. Thank you for the follow, Harkon. Good to have you here. So the advantage of this is that we can hide complexity. We need to know how to use URL-lib and Beautiful Soup, but we don't need to know how those libraries work internally. I sure don't, right? No, none of us know how Beautiful Soup actually does what it does. We just know what methods we can use to interact with it. This allows us to focus on the part of the problem we need to solve and ignore the other parts of the program. Imagine if we had to build all this stuff ourselves. Typhi, yeah, right. Yeah. I wouldn't want to build all that stuff ourselves. I just want to use the libraries that already exist. The ability to focus exclusively on the part of the program that we care about and ignore the rest is also helpful to the developers of the objects that we use. For example, the programmers developing Beautiful Soup do not need to know or care how we retrieve our HTML page, what parts we want to read, or what we plan to do with the data we extract from the web page. It's kind of similar to an API, right? Like a developer is going to build an API with a particular structure that makes it, as easy as possible for you to get to the data. They don't necessarily know or care how you're using that data. They're just making it available for you. And so as long as they create a defined structure that you're able to access, then it's up to you to access it. They don't really know exactly how you're going to use it. They just define the parameters of how you should use it. So an object is simply some code plus data structures that are smaller than a whole program. Defining a function allows us to store a bit of code and give it a name, and then later invoke that code using the name of the function. An object can contain a number of functions, which we call methods, as well as data that is used by those functions. Again, just like JavaScript, no difference here. We call data items that are part of the object attributes. All right, so once again, we can have an object. That object can contain a number of functions, which are referred to as methods. So when you see, list.sort, right? Sort is the method, and it's technically a function, as well as the data that it's used by those functions. We call data items that are part of the object attributes. We use the class keyword to define the data and code that will make up each of the objects. The class keyword includes the name of the class and begins an indented block of code where we include the attributes, which is data, and the methods, which is code. So let's look at this. So again, this is very similar to JavaScript. If you're doing OOP in JavaScript, you can essentially do this too, just a slightly different syntax. Yeah, so it's just an object. Yeah, essentially, yeah. We're declaring a new class here called party animal. And we start with we essentially define each method like a function, right? We give it a name, we give it parameters, and then this is the function logic. Again, name, parameters, function logic. Yeah. Name, parameters, function logic, name, parameters, function logic. The reason we call it a method is just because it's contained within a class. So once we've defined these methods within a class, then we can say, okay, I want to create a new variable here and have it contain the class of party animal. So once we've done that, our new variable can access all of the methods within party animal. So the first method is a specially named method called init. This method is called to do any initial setup of the data we want to store in the object. In this class, we allocate the x attribute using dot notation and initialize it to 0. So this is the initialize method here. And then we set it to 0. Now, the self keyword. You might recognize this from JavaScript, right? Do you remember that? It's been a while. Does anyone remember something similar that you might have seen in JavaScript when we covered OOP in JavaScript? What's similar to self? Yeah, Matthias and null, exactly. This, right? It's like the this keyword. We're essentially referring to the parent of the method in simple terms. I'm sure they'll talk about that in a minute. So the other method is named party. These methods all have a special first parameter that we name by convention self. The first parameter gives us access to the object instance so that we can set attributes and call methods using dot notation. So there was a lot of words there, but it's essentially saying the self parameter gives us access to the other stuff that's in here, right? So we can call, we can kind of reach outside of this method to the other elements that we have in here and, call them or modify them or do things with them. So we can refer upward from outside of the scope of this method to its parents by calling self. So self is this. Yeah, essentially. So just as the def keyword does not cause function code to be executed, the class keyword does not create an object. Instead, the class keyword defines a template indicating what data and code will be contained in each object of type party animal. The class is like a cookie cutter, and the objects created using the class are the cookies. Yeah, so the class does not actually get created until we call it. So it doesn't actually get created until we use that cookie cutter to create a cookie like we've done here. Here, we're just creating the cookie cutter. We're defining its shape, how big it is, etc. And then from here, we're actually using that cookie cutter to create a cookie. I know, cookies, right? Don't make me hungry. Now I want another Jaffa cake. You don't put frosting on the cookie cutter, you put frosting on the cookies, and you can put different frosting on each cookie. So this is the first, like I was just saying, this is the first executable line of code right here. This is where we instruct Python to create an object or instance of the class party animal. It looks like a function call, right? Because we've got the name of the function and then we've got the parentheses. It looks like a function call to the class itself. Python constructs the objects with the right data and the methods and returns the object, which is then assigned to the variable an. So now, once we've done this, we essentially say, okay, Python, go look at this class and associate all the methods in this class and all the data, etc., attributes, everything. Associate all of that with the variable an. And then once we've done that, we can call those party animal methods directly on the variable an. Thank you for the follow, Muad12300. Thank you so much. So essentially, this is quite similar to the following line we've been using all along, right? We're calling the dict class or dictionary class and assigning it into the variable counts. And once we've done that, we can call any of those dictionary methods from the counts variable directly. We construct an object using the dict template, which is built into Python, we knew that, returns the instance of dictionary, and assign it to the variable counts. Oh, thank you for the hydrate. Yeah, we'll have another Jaffa cake at our next break, definitely. It's not like I've already eaten an entire sleeve of them. Oh my goodness, I've eaten half the box already. It's bad. All right. When the party animal class is used to construct an object, the variable an is used to point to that object. We use an to access the code and data for that particular instance of the party animal class. So we can see here, we can call the party method directly against an now. So each party animal object contains within it a variable x and a method and function named party. When the party method is called, the first parameter, which we call by convention self, points to the particular instance of the party animal object that party is called from. So within the party method, we see this line, self.x equals self.x plus 1. So the syntax using the dot operator is saying the x within self. Each time party is called, the internal x value is incremented by 1 and the value is printed out. We could also do this. We could say the name of the class directly, call the method against that class, and pass in an. We access the code from within the class and explicitly pass the object pointer an as the first parameter. You can think of an.party as shorthand for the above line. And I think most commonly this is what you'll see is, we've given that variable sort of the template of that particular class. And then from there, we can say, okay, this variable now refers to a particular instance of this class. And so we can call the class methods directly against it. So when the program executes, it produces the following output. So each time we call it, it's going to increment the value of x by 1 because the value of x is being stored within that party method. And each time we call it, it's going to increment the value by 1 and restore it within x. Okay? Git says we need to do a different stream snack every week. Maybe I'll try the strawberry Jaffa cakes next. It's still like JS? Yeah, it is. It is. And that's, kind of the idea here is, so both JavaScript and Python, are C-based languages, right? So they share a common ancestor. And so you're going to see similarities like this in terms of just sort of basic properties. Mazzilli says, do you say Jaffa cakes? Yeah. So I'm an American, if you couldn't tell. And we don't really have Jaffa cakes here. It's just not something that is a popular snack. But I've always heard it's very popular. I've always, whenever I watch media from the UK, they always mention Jaffa cakes, and I'd always wondered, I didn't even know what they were. And then I went to a local Aldi, which I believe they call like Lidl or something in the UK. And they actually had Jaffa cakes on sale, so I bought a pack, and they're so good. I love them. I was just talking about how delicious they are and how I've eaten half the box. Yeah. I did, but yes, I did say Jaffa cakes, and they're amazing. I got the orange flavored ones. They're so good. TV Josh says, Python is C-based? Yep, it is. C syntax, baby. Mazzilli's, oh, you're a Brit in Indiana. That's awesome. My dad sent us some for Christmas. We have Aldi and Lidl. Oh, that's great. Yeah, that's awesome. So my grandfather was actually English. He was from Bristol, UK, and he came over during the Great Depression. So I've always kind of been interested in the UK and in Britain, especially just because my grandfather was British. So yeah, Aldi is Austrian. Okay, yeah, I don't really know the Lidl is Germany. Okay, yeah. You joined the right stream. Oh, that's great. It's good to have you here. Yeah, I like having you here. Feel free to stick around. The next thing we're going to be covering is databases, SQL and databases. So feel free to stick around if that's something you're interested in. Yeah, Ghibli says, funny, I just learned that Python and JavaScript are descendants of C. Universe doing some space rep for me. Yeah, C syntax. We are working on learning. Yes, we're working on learning Python specifically. We're working through a Python course. Yeah, working on a Python course. This is just a quick lesson on object-oriented programming. Next, we're going to be covering interacting with databases with Python, which should be a lot of fun. And learning about Aldi, apparently, which I appreciate. I go to Aldi every week. All right. Anyway, let's get back to it. So we were just talking about classes. As we have seen, in Python, all variables have a type. So we can use the built-in dir function to examine the capabilities of a variable. We can also use type and dir with the classes that we create. So once again, we have our class called party animal. We're defining its data and its methods. And then from there, we can also say, okay, if I assign this variable an with the class of party animal, then I can also say, what is the type of this variable? How can I interact with this variable? What are the methods I can use to interact with this variable? What is the type of the X value within that class? And what is the type of the party method within that class? Joey says, are you the official continuation of 100 Devs? I am still associated with 100 Devs, absolutely. I wouldn't say I'm a continuation. 100 Devs is not doing any current live classes. However, I do cover 100 Devs content quite often. So this Python course is a little bit unusual. It's not directly associated with 100 Devs, but if you would like my 100 Devs content, all of that is on my YouTube channel. Which is ad-free, by the way. I don't have it monetized. So you can head over there if you're interested in 100 Devs content. And we will be getting back to more sort of MERN stack 100 Devs content once I'm done with this Python course and we've built something with it. But yeah, so right now we're kind of doing an offshoot. This isn't strictly 100 Devs content, but if you are in 100 Devs, you're welcome to tune in because I think it's still useful to learn, right? I am, yes, I am definitely associated with 100 Devs. I'm a mod on the Discord. I'm listed as an instructor on the website. And once cohort 3 starts, whenever that is, I will be, doing some official teaching with the next cohort. But for now, this is more of, general learning and fun with coding and exploring different languages. Children of C, new band name. Played around with C, don't if you don't have to. I mean, yeah, there's use cases for every language, right? David Sling, welcome to the stream. They say you must be C++ wizard. No, actually, I've never worked with C++. However, those sort of syntaxes and concepts are applicable across multiple languages, especially those who are in the C family, like Python and JavaScript. So the nice thing about learning a language is that it makes it much easier to learn your next language, especially if they're in the same family. So for example, I've previously learned JavaScript. So now we're able to directly apply those sort of object-oriented programming concepts to something like Python because they're shared across both languages, which is pretty cool. All right, anyway, so we're calling type on these various aspects, type and dir on these various aspects of party animal here. So let's see what we get. So for the first one, if we call type against the class itself, we can see that we get class main dot party animal. And if we call dir against this instance of party animal, it's going to give us a list of methods that we can use to interact with it, right? And we can call any one of these methods against party animal. If we call types strictly against x, so this value of x that's contained within party animal, that gives us a class of int, which makes sense, right? X is just an integer that stores a number. However, if we call type against the party method, that's going to tell us that it is indeed a method. Azealia says that's nice to know. Yeah, absolutely. You want to seriously start developing games. That's very cool. Yeah, there's a lot of really cool people here in the software and game dev space on Twitch who are developing games and doing it live. I would, I'm not strictly a game developer, so I'm a data engineer. My day job is I'm a data engineer, and then here on Twitch I mostly teach web development. So I really don't do much game dev, but there's a ton of really cool people who are doing game dev in the same category on Twitch. So you might want to check them out if you're really, really interested in games, because I think that's awesome. So many people are just coding live and developing their own games. Suri, thank you so much for the follow. Good to have you here. Alrighty, so let's talk about the object lifecycle. In the previous examples, we defined a class. We used that class to create an instance of that class. So by that we mean, when I said an, or when they said an equals party animal, we're creating an instance of the class. And then we use that instance. When the program finishes, all of the variables are discarded. Usually we don't think much about the creation and destruction of variables, but often as our objects become more complex, we need to take some action within the object to set things up as the object is constructed and possibly clean things up as the object is discarded. If we want our object to be aware of these moments of construction and destruction, we add specifically named methods to our object. So we can say here again, we're redefining party animal. This is the first initialization here. This is the party method. And then this is the destruction here. So init and del for, delete, I guess. So when we execute this program, when we call the party method, it's going to print so far. If we call it again, it's going to increment x by 1 and print 2. And then if we call, so if we set an equals 42, then we call this print. We're going to get I am destructed 2, and then an contains 42. Okay, so as Python constructs our object, it calls init to give us a chance to set up some default or initial values for the object. When Python encounters the line an equals 42, we're actually throwing away this instance of the object, right? Because we're reassigning an to a new value. So we call party twice on this instance of party animal, but then when we get here, Python's like, oh wait, I guess I don't need this instance anymore. So it's going to throw the object away. It's going to destruct it. Our destructor code, del, is called, and we cannot stop our variable from being destroyed, but we can do any necessary cleanup right before our object no longer exists. So that's what that del is for. It says on destruction, do something. When developing objects, it's quite common to add a constructor to an object to set up initial values, but it's relatively rare to need a destructor for an object. I don't know that I've ever seen one. Have you all? Hey, ResCoder, good to have you here. Killer Code said, I played the game Control, and now all these things confuse me. Yeah, Control is great. I have a really bad habit of playing games almost to the end and then like stopping. So I never finished Control, but it was really great. And then I went back and tried to play it again recently, and I couldn't remember anything. And so I'm going to have to play it again from the start and try to finish it this time. Suri says, that makes so much more sense now about class objects. Yay, that's what I'm going for. I'm glad that was helpful, Suri. Thank you for that. Yeah. No, for me, the whole class and instances and that type of thing has always been a little bit fuzzy for me too, which is why, this is worth going over, even if it's not, something we really have to think about all that often. Yeah, look up Control, Mazilius. It's a really fun game. You might like it, depending on what type of game you like. Yeah, exactly. As Joey said, destructors can be useful to close out resources like files or database connections. Right. So especially when it comes to, I'm especially thinking in terms of like database connections, right? You don't want to have a lock on something that you're not using anymore. So each time you are done with that resource, you want to make sure you're freeing it up so that other people can use it. And I guess same with files too, right? How sometimes you might open in a Word document or an Excel file or something, and it's like, oh, your coworker has it open, and then you have to send him a Teams message and be like, hey, close this file. And so that's kind of what we're talking about here with this del is like, hey, all right, let's say I'm accessing a database. When you're done with that, when you no longer need that resource, you want to make sure you're releasing your hold on it, you're releasing that lock so that other people can use it. Yeah. So far, we've defined a class, constructed an object, used that object, and then thrown the object away. However, the real power in object-oriented programming happens when we construct multiple instances of our class. Yes. So essentially, the whole point of this is that you're creating a structured kind of an object that can be reused, right? Similar to when we declare something as a list or when we declare something as a string, right? That's a built-in template that's built into Python. It's a built-in object that has associated methods that you can use over and over and over and over and over again, and it's going to have the same structure each time. So we can build our own stuff like that. When we construct multiple objects from our class, we might want to set up different initial values for each of the objects. We can pass data to the constructors to give each object a different initial value. So what we can see here is that in the initialization method, we've added an additional parameter, right? So we still have the self parameter, but now we have a new parameter called name, or NAM. So now in this case, we're still declaring x as 0, self.x is 0, but we can set this second value to be whatever is passed in on the initialization of that object. So in this case, we can say s and then call party animal and pass in the name Sally. And so that's going to get passed in as the second parameter here. X remains 0, but this self.name is now set to Sally. And then we can call party, and that will use that value of Sally in the print statement. So each time we call it, we can pass in a different initial value if we want. So the self parameter points to the object instance and additional parameters that are passed into the constructor as the object is constructed. Within the constructor, the second line copies the parameter name that is passed into the name attribute within the object instance. And the output of the program shows that each of the objects contain their own independent copies of X and name. Right. So each time we call it, it's declaring a new instance of self and a new instance of name, and those can be different. No, it's okay, Mazilius, you're fine. A copy of a copy of a copy. Yeah, really. And it's really just like, it's like that cookie cutter thing, right? We set up a class as a cookie cutter. And then from there, let's say the cookie cutter is shaped like a Christmas tree. You can cut out multiple Christmas tree cookies and decorate each one in a completely different way. They're still going to have the defined shape. They're all going to have the same defined shape of a Christmas tree, but you can put different frosting on it. You can put different colors. It's still going to be identifiable as a Christmas tree. It might just have a slightly different look. Yeah. So that's really what we're doing here is with this class, we can use it as the template. And then each of those instances of that class could have different outcomes, right? Different appearance, different properties, different behavior, falling within the definition of that class. So finally, let's talk about inheritance. Another powerful feature, yeah, Jaffa cakes with the different fillings, exactly. You could have orange and strawberry, but they're both going to be Jaffa cakes. Another powerful feature of OOP is the ability to create a new class by extending an existing class. When extending a class, we call the original class the parent and the new class the child. So they move the party animal class into its own file, and then we can import the party animal class in a new file and extend it as follows. This should be pretty familiar. Again, this is another property that exists in JavaScript. You can do this in JavaScript exactly how we're doing it here in Python. So we're importing party animal, and then we're creating a new class called CricketFan. So we're defining the CricketFan class, and we indicate that it extends the party animal class. So all the variables and methods from the party animal class are inherited by CricketFan. So, for example, within this new method called 6, we can call the party method from party animal because it's inherited from its parent, which is party animal. We use a special syntax in the init method in CricketFan to ensure that we call the init method in party class as well. So we can see here what it's doing is we're saying, all right, initialize CricketFan and then go upwards using super. Using super, we also want to initialize the parent party animal so that we can, call methods and stuff on it. Puppy extends dog. Yeah, exactly. So whatever setup that party animal needs is done in addition to the setup needed for the CricketFan extensions. The super syntax is telling Python to call the init method in the class that we are extending. Party animal is the super or parent class, and CricketFan is the sub or child class. As the program executes, we create S and J as independent instances of party animal and cricket fan. The J object has additional capabilities beyond the S object because cricket fan contains all of the methods of party animal plus a couple additional ones. Yeah. So, in this case, we can see that if we call the, let's see, where is that at? If we call the deer method on J, which is cricket fan contains everything that party animal does, plus a couple of additional methods. It's really JS with more space. I mean, similar syntax, right? Yeah, it's a similar, you can do a lot of the same stuff because they share a common family. So you can do a lot of the stuff that you can also do in JavaScript. Mazzilli says strawberry? Yeah, there's strawberry Jaffa cakes at the store as well. I got the orange ones. I didn't get the strawberry ones. Yeah. Matthias says, looks much more natural than classes in JavaScript. I would agree, yeah. Although, just visually they are similar. Yeah. So in essence, you can define classes, which are essentially objects. Classes can contain both data and functions that are associated with that class. And so when you create an instance of that class, whether you've defined it or whether you are using one of the built-in classes like that Python has, like list or dictionary, if you create an instance of that class, you can access the methods and the data that are stored within that class. You can assign that to a variable or you can access it directly. You'll often see it done being assigned to a variable, and then you call the methods directly on that variable. So that's the gist of it. Thank you for the follow, E2DS23. Thank you so much. Good to have you here. Thank you for the follow, David Sling. Good to have you here as well. Okay, so real quick, let's do the quiz on this. I did peek at this. It's not terribly long, so we're just going to blow through this quiz because we're rock stars, and then we're going to get to databases. All right, which came first, the instance or the class? Which came first, the chicken or the egg? Which came first, chat, the instance or the class? Based on the vocabulary that we've just learned. Yes, it's going to be class. Because what is an instance, chat? What is an instance? Yeah, E2D, welcome to the stream. What is an instance, chat? Yeah. It's an object using that class template, right? It's when we actually use that cookie cutter to create a cookie. Yeah. So the class has to be created first. We need the cookie cutter before we can use it to make a cookie. Yep. All right. In OOP, what is another name for the attributes of an object? Is it fields, messages, portions, methods, or forms? What do we think, chat? David says fields. Suri says methods. E2 says fields. Null says fields. Duchess says fields. Any other guesses? Methods are functions, yes. I do want to look back at this one really quickly. I'm not doubting that it's fields. I'm just remembering it as methods. So I want to see what I misinterpreted about that. So we'll go to, let's see, the question was attributes. So I remember reading about it, but okay. An object can contain a number of functions as well as the data that is used by those functions. We call data items that are part of the object attributes. Okay, so attributes and methods are different. Okay, that's what I misinterpreted. Yeah. Methods and functions describe behavior. Yeah. So I misread that to be that the methods are the attributes, but they're two separate sides of the coin there. Now, it doesn't say strictly what they are, but let's go back here. So yeah, I guess we'll say fields because that seems to make the most sense. We'll see if that's right or not. All right. Which of the following is not a good synonym for class in Python? Is it A, template, B, pattern, C, direction, or D, blueprint? What do we think, chat? Yeah, I think I would agree with that. The rest of these are, template. We're talking about cookie cutter here, right? It's a template. It's a pattern that we can use. It's a blueprint. I think I've used all these words when we've been talking about this section, right? The one we haven't used is direction. Yeah, and this could be tricky if English isn't your first language, but I do think this is the least valid answer. All right, question 4. What does this Python statement do if party animal is a class? So zap equals party animal. Does it A, copy the value from the party animal variable to the variable zap? B, subtract the value of the zap variable from the value in the party animal variable and put the difference in zap? C, use the party animal template to make a new object and assign it to zap? Or D, clear out all the data from the party animal variable and put the old values in zap? What do we think? Yeah, I agree. This is C. We're using our cookie cutter to create a cookie. We're creating an instance of party animal. Yes, good job, chat. We're creating a new object and assigning it to zap. Okay, what is the syntax to look up the full name attribute in an object stored in the variable Colleen? Let's see, it would be, is it going to be Colleen and then arrow full name? Colleen, again, arrow full name. Colleen : full name. Colleen dot full name. Or Colleen square brackets full name. Mazilia says, I like this way of learning. Hey, yeah, I do too. That's why we're doing it. It's pretty good. Yeah, I'm going to say D here as well. This dot syntax. Yep. 4D, yeah, what chat says. Yeah, I'm going to agree with this because essentially if we want to access a method or an attribute that's stored within that class, we would use the dot syntax in order to access it. That's not to say that maybe these other syntaxes could be used in other languages. Those are some of the things that we see sometimes with the quizzes being a little tricky. And this is valid syntax too for looking something up, for example, within like a dictionary, right? But in this case, I think this is the most accurate answer for what we're trying to do. Yeah, exactly. Accessing items from a list, maybe, right? All right, which of the following statements are used to indicate that class A will inherit all of the features of class B? Be careful with this one. Be careful with this one because it could be a little bit, this is where there's maybe some syntax differences between languages you might already know and Python. All right, is it A, class A extends B? B, class A inherits B? C, A equals B++? D, class A parentheses B? Or E, class A instance of B? What do we think, chat? Let's look at this one. Let's look at this one. All right. Yeah. So a lot of chat said A. I think that's correct in JavaScript. Let's look at how it's done in Python. So you're not wrong, but in Python, you're going to do it like this. Yeah, gotcha. Gotcha. I knew that was gonna, as soon as I read it, I was like, that's gonna trip him up. But that's not a bad thing, right? It's one of those syntax differences we got to remember. So here we're defining the new class of cricket fan, which is going to inherit the properties of party animal, right? Yeah. So in JavaScript, you would use that extend keyword to have that new class inherit the properties of whatever it's extending. But in this case, in Python, you're going to do it like this. It's kind of like you're passing in party animal as a parameter into CricketFan, or as an argument into CricketFan. And so CricketFan can sort of ingest all of the properties of party animal and use them. If you want to think about it like that way, you can think about it like we're declaring a function and we're passing in party animal to that function, so that it can eat that cookie, right? If we're still going back to cookies, it can eat that cookie and have everything that was contained in that cookie. Killer Code says, how do you say it in English what the dot does? We say the dot hands it over. I would probably say it accesses it. It's like you're going within the class, or within the you're going within the class to access that method. I think that's probably how we would say it. But hands it over isn't bad. I mean, it still makes sense. We just probably wouldn't say that. We might say access that method or use that method. Yeah. All right. So anyway, the answer here, I believe, is going to be D. Yeah. Making sense? Okay, good. E2 says, in Java, one of the concepts I'm having trouble understanding is interface. Does Python support it? Interface. I'm not quite sure what you're referring to, but that doesn't mean it doesn't exist. That just means that I'm not aware of it. Because I don't know Java, so I don't really have a reference point for you there. Oh, thank you, Joey. That's helpful. Python doesn't have interfaces the way Java does, but it has the concept of abstract base classes. Okay. Interfaces are classes with methods that have no bodies. Interesting. Okay. That you must implement. Okay. Yeah, I'm not very familiar with that. So thank you, chat. All right, let's go to the next one here. How is self typically used in a Python method within a class? Is it A, to set the residual value in an expression where the method is used? B, to terminate a loop? C, to refer to the instance in which the method is being called? Or D, the number of parameters to the method? Remember that we can equate the self keyword to the this keyword in JavaScript. So if you're familiar with JavaScript, you can think of self as being similar to this. So what do we think the answer is then? Yeah, I'm thinking C as well. We're essentially saying self is referring to the class in which the method is contained. So it's like you're almost like you're going up to the parent level, and that's giving you kind of a bird's eye view of the elements of that class that are outside the scope of the method you're currently inside. So it kind of gives you the ability to reach upward outside of the scope of your current method and access other elements of that class. All right, what does the Python dir function show when we pass an object into it as a parameter? So if we pass something into dir, what is it going to show? Is it going to show A, the parent class, B, the number of parameters to the constructor, C, the methods and attributes of the object, or D, the type of the object? Just an endless stream of C's here. Yes, and yes. So if we call dir against an object, it's going to show the methods and attributes of the object. And this could be really useful. This could be really useful for you if you're working with, a custom class, or if you're working with just a class you haven't used very often. You can call dir on it, and essentially you can think of dir like directory. I don't know if that's what it stands for, but that's how I'm thinking of it. So if you want a directory of all the different ways you can interact with that class, then calling dir on that class or directory is going to give you that listing, kind of like an old phone book, right? I don't know if how many folks in chat are old enough to have actually ever used a phone book, but we used to call it a telephone directory, right? So it was a directory. It was a listing of all the different people you could interact with in your neighborhood. So calling dir on a class is going to show you all the methods that live in that class that you can interact with. The white pages. Yeah. Hey, Funke, welcome to the stream. Oh my goodness, thank you so much for the sub, AJ. I appreciate that. AJ wants your pizza. I want pizza too. We've been talking about cookies and Jaffa cakes this whole time. Thank you for the follow, Funke. And thank you for the sub once again. AJ wants your pizza. I want pizza now too. I might actually have to go and get one after the stream. Y'all are making me hungry. Why did you do that? No, thank you so much. I appreciate it. It's all good. It's all good, Killer Code. So I'm actually old enough, and I'm not like that old. We just live in a very rural area, but I'm actually old enough that when I was little, the very first phone I ever learned how to use was a rotary phone. You know, the kind where you put your finger in the little dial and you have to spin it around. That was our main house phone. Was a rotary phone. It didn't even have touch tones, and so if we called a oh my goodness. Thank you so much for the 2-month streak. My goodness. I appreciate that so much. That's so kind of you. Wow. Thanks for the double sub, Pizza. Great to have you here. So cool of you. But yeah, so I grew up using a rotary phone. And so whenever we would call like a phone menu that would be like, press 2 to, press 2 to access the operator or whatever. Press 2 to place an order. Those did not work with rotary phones. You could not use a rotary phone with those menus. And so we would have to say the number out loud. We'd have to say 2 into the receiver in order to get past the menu because we didn't have a touch tone phone. So weird story, but yeah. Gotta eat the pizza like a python. Oh Lord. All right, last question, chat. Let's get this done. It was just one. I don't know. I got 2 sub notifications there, Pizza. So if you sub twice accidentally, feel free to if you get double billed, feel free to cancel one of them because I got 2 notifications. So it could be just Twitch glitching out. That's not the first time, but I got a Prime sub and then I got a just a regular sub notification. So just FYI. No worries. It's still either way. It's great to have you here, Pizza. All right, last question. Which of the following is rarely used in object-oriented programming? Is it A, inheritance, B, destructor, C, attribute, D, constructor, or E, method? Yes, it's going to be B, destructor, right? That was mentioned briefly, just that, it's just not, you can use them to do things like releasing locks or closing out services, that type of thing, but it's not commonly used. So let's go ahead and submit this. Good job, chat. All right. 100% first try. Good job, everybody. Way to go. Nice. Killer says, we had a fax phone, giant heavy. My goodness. Wow. All right, chat. We're going to take a quick break. And when we come back, we're going to finally get to the good stuff. We're going to get to databases. So databases, we're going to talk about just general database architecture. We're also going to do a little bit of SQL. So if you've never done SQL before, I have a couple of intro to SQL videos on my YouTube channel. I am a SQL developer. But this is also a good, this chapter is also a good introduction to SQL. No worries, Ms. Illies. It's great to have you here. Please come back again. And all my streams are recorded also. So you can watch this after it's over. You can watch it on Twitch. Or you can watch it later on YouTube. So you have options. You don't have to miss the content. Yeah, so I'm a SQL developer. And so this is going to be review mostly for me. But if you've never learned SQL before, this should be a decent introduction to just general properties of databases. Yeah, I do have a YouTube. You can do !YouTube for a link to my YouTube channel. Or you can just search for Mayan Wolf streams on YouTube, either way. Alrighty, folks, we're going to take a break. When we come back, I swear this is the good stuff, so please stick around. I love talking about databases. I love talking about SQL, and so this is going to be a lot of fun for me. And we may not get through the exercises, just depending on time. We may do those at the start of the next stream, especially we're going to definitely do the quizzes at the start of the next stream. There's a fair amount of exercises with this one. So we'll just see how much we get through. I would like to get through the content at minimum, and then maybe we'll do the exercises next time. But we'll see. If we're having fun, we might just keep going. I don't know. This will be the test we failed. Nah. SQL looks hard, but it really isn't. It was designed to be, so SQL was designed to be written as readable as possible to people who had never touched a computer before. It was created back in 1977, before most people had ever even seen a computer in their lives, and computers were still the size of, shipping containers, right? And so SQL is constructed to be a friendly language, and it really is. Now, you can do a lot of complex things with it. You can make it look very unfriendly, but for the most part, basic SQL is extremely readable and extremely writable. Yep, it's very easy to use and remember, exactly. And it's also the absolute best way to talk to databases. A lot of people will say, well, I could just use a JavaScript library, or I could use a GUI to look at my database data. Absolutely, I'm not denying that. But that's an interface layer between you and the data. If you want to talk to your data, if you want to be able to access and retrieve your data in the most direct way possible, SQL is the way to do that. So, all right, 5 minutes, folks. When we come back, we are going to learn some SQL. Let's go. Alrighty, Conra17 and Oflake, thank you so much for the follows. And once again, thank you to Pizza for the sub. I appreciate that. All right, I'll see you back here in 5 minutes for some SQL. Stick around, folks. This is going to be a good one. Alrighty, folks, we've got about a minute left in the break, so please come on back if you're coming back. Make sure that you've got some hydration. Make sure that you are stretching if you've been sitting this entire time. And as always, please pet your dogs, pet your cats, pet your significant other with their permission, of course, and then come on back. Alrighty, welcome back, everybody. Great to see ya, and have a special treat for you here, chat. Check it out. It's a Jaffa cake. These are the orange ones. I had to get one after we've been talking about it for so long. Jaffa cake. This is for anybody who doesn't know what they are. It's like a cookie, kind of. It's almost like for the Americans, it's almost like a fig Newton, except with like a chocolate coating on the top, and it's shaped like a circle. But yeah, it's got like a fruit filling. They're really good. No puppy, just Jaffa cake. But yeah, this is what we were talking about the entire time. So I'm gonna finish chewing, then we'll get back to it. All right. Suri says, quick question. Do you know Apple Swift coding as well? Or know someone who streams it? My son is taking a class for it. That's awesome. And we're both having a hard time getting into it. So I personally don't know Swift, but someone in chat might. So chat, feel free to direct them towards any resources that you might know. There's also a lot of really awesome people in the same category here on Twitch. So people who are in the software and game dev category. So if you search around, I'm sure you can find somebody who's coding in Swift, doing live coding or doing teaching in Swift. Yeah. But chat, feel free to share any resources that you're aware of that might help them out. All right, let's get into databases, folks. This is the good stuff. This is the stuff I'm excited about. Definitely. I'm excited about all of it, but I'm really excited about databases. Anytime I get the chance to talk about databases, I am pumped. All right, let's get into it, folks. So, what is a database? I'm sure you've all heard of databases, and honestly, databases run the world. Databases run everything in the modern world that you are used to interacting with, pretty much. A database, at its core, though, it's just a file that is organized for sharing data. Most databases are organized like a dictionary in the sense that they map from keys to values. The biggest difference is that the database is on disk or other permanent storage, so it persists after the program ends. You're looking forward to see how I actually use this stuff. Marsevich, thank you so much for the follow. But yeah, so essentially, it's different than a file in that a database is on disk or permanent storage, and it persists after the program ends. So it's kind of like a warehouse for your data. Right? So you can put it in there and you can access it again at any time. You can also organize the data. Because a database is stored on permanent storage, it can store far more data than a dictionary, which is limited to the size of the memory in the computer. Yes. So just like a warehouse, it's a way to offload your data and organize your data so that it's not cluttering up the space that you're using all the time, right? Anytime you can go out to that warehouse and you can retrieve the data that you want and bring it back. And then when you're done with it, you put it back in the warehouse. You might change it or you might not. You might just read it. You might update it. You might create new data, new things to put in the warehouse. But either way, it's a way to kind of offload some of that storage. Delegation of tasks. Thank you so much for the follow. Like a dictionary, database software is designed to keep the inserting and accessing of data very fast, even for large amounts of data. Data software maintains its performance by building indexes as data is added to the database to allow the computer to jump quickly to a particular entry. There are many different database systems which are used for a wide variety of purposes, including Oracle, MySQL, Microsoft SQL Server, PostgreSQL, and SQLite. We will focus on SQLite in this book because it is a very common database and it's already built into Python. So you'll hear me sometimes refer to these as flavors of SQL or SQL. Now, SQL is more of a standard it's more of a standard, like a language standard, than it is a language in itself. Because within that language standard, you can have multiple different flavors of SQL. I myself in my career, I've worked with Oracle, I've worked with Microsoft, I've worked with Postgres. SQLite is new to me, but the cool thing is that once you've learned one flavor of SQL, you can pretty easily migrate to other flavors. There's just going to be some minor syntax differences, some functions that exist in one flavor, not the other, et cetera, et cetera. And so, people often ask me, what flavor should I learn first? And I'm just like, any of them? I don't know, whatever's free, like learn that one. Postgres is a great place to start because it has a lot of free online tools that you can use it with. So I often recommend Postgres. But SQLite is fine too. SQLite is a little bit lighter, I guess, than these other flavors. So, either one is fine. Delegation says, welcome to the stream, by the way. They say, can warehouse reduce size of data? Potentially, depending on how you structure your database. And I think we're going to talk about that a little bit later on. If you have a lot of repetitive data, a lot of data that is duplicates or close to being duplicates, you can use a well-constructed database to join tables in such a way that it can reduce the amount of data that you are storing without losing any of the data. So if that doesn't make sense, that's okay. We're going to talk about that a little bit later, I think. Yeah, and that's also, I would recommend Postgres over SQLite. I mean, SQLite is what this book uses, and that's fine for basic stuff. But I would recommend Postgres because, yes, SQLite is kind of like a stepchild of SQL a little bit. It's missing some features. It's a little bit different. And that's not to say it's bad. It's just if you want to get good knowledge of SQL overall, Postgres is probably the way to go. No, it's all good. What is SQL? Is it like JavaScript or something? Pretend I'm dumb and have no idea. SQL is like it's essentially a language standard that you can use to talk to a database. So within that language standard, it's kind of like, think about it like English, right? If I say I speak English, there's a general idea of the language I speak, but maybe not the dialect, right? I could be speaking American English, I could be speaking British English, I could be speaking Australian English, and all of those are going to be understandable, but they're going to have some differences between them, right? So it is a language, but there can be different dialects within that language. However, they all do the same thing. They all talk to a database and work to basically perform CRUD operations on that database. So we know what CRUD is, right? Create, read, update, delete. With SQL, you can perform those operations directly against a database. Yes, and SQL stands for Structured Query Language. So we're going to talk more about this. It's okay. You don't have to understand all of it now. We're going to keep talking about this. We're going to do examples. Don't worry. If you're like, oh my gosh, I don't understand. But yeah, we're going to talk more about this. This is just sort of the basic introduction to it. Okay, so the nice thing about SQLite is that it is already built into Python. And we're going to see that a little bit more later on. We're going to see how you can basically use SQLite directly in Python to access data. So that's a good thing about it. SQLite is designed to be embedded into other applications to provide database support within the application. So Firefox uses SQLite internally, as do many other products. And that's the nice thing about it is, SQLite, like I said, it's missing some functionality, but most of the time, maybe that's functionality you don't need. And so it makes it easier to be embedded in other things. All right. So what is a database? How does a database look? What does it mean to put together a database? Database is kind of like a giant spreadsheet. If you've ever seen an Excel spreadsheet, you know that it has rows and columns. And a spreadsheet can also have multiple tabs, right? You can have, tab 1, tab 2, tab 3, and you can have relationships between those tabs in the workbook. So you can have tab 2 referencing the data on tab 1, but they are still separate from each other. So in this case, each table in a database is going to be made up of rows and columns. And the reason we call these relational databases, so SQL databases are often called relational databases, is because each table can be related to other tables in the database. So that's why it's called a relational database, because you can have multiple tables and those tables are often going to be related to each other. In technical descriptions of relational databases, the concepts of table, row, and column are more formally referred to as relation, tuple, and attribute, but we don't use those. Don't worry about it. It's okay. Don't memorize those. I've only ever heard the people that I work with and that I use, you're going to it's going to be tables, rows, and columns. Just that's what they're going to be called, because that makes the most intuitive sense and makes them easier to talk about. So table, row, and column are all you need to remember. And just as a reminder, rows are horizontal. Shuffle pogo. I'm sorry, I said that wrong, but that's an awesome name. Thank you for the follow. So rows are going to be horizontal, and each row will generally refer to a transaction. So if I am at the store and I go to the cash register, oh my goodness, thank you so much, Marco. Thank you for the sub. That's so kind of you. You used your Prime sub. Thank you so much. I am well. Thank you, Shuffle. And also thank you, Marco. Thank you so much for the sub. Good to have you here. Educating people for free is nice. It is, yeah. I like educating people for free because that helps me learn better. So it's mutually beneficial, right? It helps me make sure I learn the data better. And yeah. I am well, though. Thank you, Schnuffle. Star Fox says, isn't a row a display of the aggregated data? Not technically the data itself. Yeah, I mean, you can get into those types of definitions of like being very strict and all that. Like, I mean, technically it's a record, each row is technically actually a transaction or a record. But in layman's terms, for the types of things we're talking about, we're just going to call it a row. It's a row, it's a horizontal element that contains all the data for a particular transaction. So if I'm at the cash register and I check out, a row could contain the product that I bought, my name, the time I checked out, and let's say the amount of things that I bought, right? So like 4 or 5 elements could contain, me, the amount, the time I checked out, and the amount of things I bought. The columns are the vertical elements. So for example, each column is going to contain a specific type of element. So for example, a particular column could contain nothing but amounts, right? This column is going to be called amount, and it's going to contain nothing but the transaction amounts. Another column is going to contain nothing but names. Another column is going to contain nothing but times. And so each of those is going to be, defining a particular element and containing only that element. Yeah. So in just to break it down even more simply, rows are horizontal, columns are vertical. So the way that this text is browsing SQL databases is by using a specific tool called Database Browser. This tool is free to download. I've actually got it installed on my machine because I was messing around with it earlier just to make sure that I could use it, that it wouldn't just break on me when I go live here. And yes, it does work. There are lots of different types of database access tools that you can use, but DB Browser is fine. There's a ton of different, ways that you can use a tool to write SQL and access your data in a database. But this text uses Database Browser. So you can download it for free right now if you would like, or you can just watch me. We aren't going to make heavy use of it. I'm going to be executing some SQL in here later on. But this is a free tool that you can use. In a sense, the database browser is similar to a text editor when working with text files. When you want to do one or very few operations on a text file, you can just open it in a text editor and make the changes you want. When you have many changes that you need to do in a text file, often you will write a simple Python program. You will find the same pattern when working with databases. You will do simple operations in the database manager, and more complex operations will be most conveniently done in Python, using Python to execute SQL, to be more exact. So you'll still be using SQL, but you'll be using Python to automate the creation and the execution of that SQL. So we're combining two separate languages here. Yes, and also, as with many things, you can also execute SQL directly within VS Code as well. So there is an extension for VS Code that you could install if you prefer. Maiva says, so is a table like a JSON object that you get, or is a table like a JSON object that you get back when fetching data? Sort of. That's more of what you would get from like a document-based database like MongoDB. But it is essentially a combination of values and properties. And you could get back any number of those values and properties depending on the criteria of your query. And I promise we're going to do some of these. It's going to be a lot clearer once we actually start executing some queries. All right, so if we wanted to build a database, how do we create a database table? So as I mentioned earlier, you can run CRUD operations with SQL, just like you can with something like JavaScript in MongoDB. So you can do create, read, update, delete. So how do we create a database table? Well, databases require more defined structure than Python lists or dictionaries. When we create a database table, we must tell the database in advance the names of each of the columns in the table and the type of data that we are planning to store in each column. When the database software knows the type of data in each column, it can choose the most efficient way to store and look up the data based on the type of data. So this is a little bit different than how you might do it with a MongoDB database, right? Relational databases require that you strictly define the structure of the table first. So you have to define all the column names and the data types that you're going to be storing in each column. And it supports various data types. I mean, it's going to be all the ones you're familiar with: Booleans, strings, integers, floats, etc., the common ones. Defining structure for your data up front may seem inconvenient at the beginning, but the payoff is fast access to your data, even when the database contains a large amount of data. Just based on what you all know from designing web applications, what's another advantage of defining all your data types up front? Can we think of another advantage of defining all your data types up front? Before data is entered? What might be another advantage of this? Besides it being quick, yes, besides it being quicker to look up. Think about what happens, what if your application maybe didn't have good data sanitization on the front end? Yeah, it keeps bad data out, just in general terms, right? Because if, let's say we're talking about the cash register thing, right? Let's say that, if maybe I'm the clerk and I'm entering data, into the cash register. Let's say that I accidentally put the amount, or let's say that I accidentally put the name of the item purchased into the amount field. Now, a good cash register wouldn't allow that, right? But let's say that I accidentally did it, and let's say that we didn't have good error handling. If I tried to write a string into a float column, so to speak, if I tried to write a string into a column that's been defined as a float, the database will not allow that record to be written. Because we've predefined that data, it's going to say, hey, this isn't this isn't going to be the type of data that's supposed to go in this column. It's not going to allow that right. Yeah. Matthias says, my database only has ints if I only want ints. Yeah, you define the type of data that gets written into that table for each column. You're going to define each column individually, and we're going to see that in just a minute. You define each column individually, and you have to define the data type for each. So again, it seems inconvenient because, oh my gosh, I have to know what type of data is going to be written into each column, but that is the trade-off. All right, so let's do a little bit of SQL here. Thank you so much for the follow, Estratu. Thank you so much. Good to have you here. All right, SQL time. So we're going to create a new file here, and we'll call it. Let's see if y'all can see that. Good. We're going to call it SQL create.py. And so here we're going to be using a combination of Python and SQL. So I'll identify which parts are Python and which parts are SQL, but we should be able to tell pretty easily. So we're going to import the SQLite library. Essentially, this is going to allow us to execute SQL. And then we are going to connect to a database called music. This database doesn't exist yet, but this execution is going to create the database. Then we're going to define a cursor. Don't worry about that for now. We're going to talk about it. And then we are going to execute two separate SQL statements. So chat, what do you think this first statement does? Just by reading it. I'm not going to tell you up front. What is this statement? What do you think this statement does? What do we think, chat? Cares about not having duplicates? Duplicates of what? Yeah, it says we're going to drop a table if it exists. And the table we want to check for is going to be called track. So we're going to say drop table if a table called track already exists. Yeah. So the arrangement of the words might be a little bit different than how you would write it in an actual sentence, but all these words do exactly what they say they're going to do. So there's no, weird vocabulary here. All these words do exactly what they say they're going to do. So drop a table if it exists, and the table we want to check for is called track. All right, let's look at the second statement here. Yes, it's not caring about duplicates, but if we have one already, we deleted it. Exactly. If the table already exists, we want to drop it. And what do we think is happening here? Just the first part. Don't worry about the second part yet. What's this one doing? It creates something. Yeah. Suri says making a new table called track. Yeah. We're creating a new table called track because we've gotten rid of the old one. If it was already there, we've gotten rid of it. So now we want to recreate it, essentially. And the second part Let's see, I'll drag this over a little bit more. Can't quite see it. There you go. So the second part is essentially doing that definition that I was talking about. Remember how we said that with a relational database, you have to define your columns up front. So what do we think this part is doing then? We're defining our columns up front. So he says column names. Yep. What else is this doing? We're setting column names and what else? Yeah, they're data types, right? So this table is going to have two columns. It's going to have one called title with a data type of text, and then the second one called plays with a data type of integer. Okay? And then after that, we're just closing the connection. It's kind of like a console log, except here we're actually setting up a structure that this is a permanent structure. So a console log is temporary, right? The console log prints once and then it's gone. But this is a structure that will remain. We are then going to be able to write records into this table. We're going to be able to write rows into this database table that matches this structure. So each row that we're going to write is going to have a title and plays. Yes, and this is closing the connection. So that way, I kind of talked about it earlier, so that way we don't lock resources, right? We allow others to interact with this table. All right, so let's go ahead and run this, and then I will show you what that looks like. What we've just done. All right, so save this, and I'll run Pi. Thank you so much for the follow, Catafracto. Good to have you here. All right, so Pi SQL create.py. So it's not going to look like it did anything. So you're going to be like, okay, what happened? What did it do? But I will show you. Oops, there we go. We now have a new file called music.sqlite right here. And if I try to open it directly in VS Code, I can't open it. So as GetAlpine, to answer your question, GetAlpine, this is creating your local database. We've just created it. So the database is contained in music.sqlite. So this database now contains one table called track. We can't open it directly in VS Code because it's not that type of a format. We have to open it in a database browser, something like DB browser here. So if I go here and I open database, drag it over here, you guys don't get to see my file structure. Not that I don't trust you, but you know. All right, I have just opened the database here in DB browser. And we can see that I have one table. I can maybe zoom in here a little bit. I don't know, can you all see that? But you can see here under tables, I have one table and it has two columns. One is called title and the other one is called plays. Type of title is text and type of plays is integer. So that's what we just defined. All right. So that's what that statement did. It created our database. And it set up our data structure. Now, there is nothing in this table yet. We have not written any records to the table. We've only defined the structure. So the connect option makes a connection to the database. And if the file does not exist, it will be created. So that's what we just did. The reason this is called a connection is that sometimes the database is stored on a separate database server from the server on which we're running our application. So this is how we generally interact with databases, right? Is if you talk to MongoDB, it's stored in the cloud. We've done stuff with Supabase, right? That's another cloud-based database solution. So you're interacting with an external data storage place using a connection. Yeah, and I can show the code again. Yeah. There you go. I'll drag this over. I'm going to have to kind of arrange things so that I can show the code and read at the same time. But this, we go. Okay. In our simple examples, the database will just be a local file in the same directory as the Python code we are running. A cursor is like a file handle that we can use to perform operations on the data stored in the database. Calling cursor is very similar conceptually to calling open when dealing with text files. So essentially what all the cursor is really doing is kind of almost kind of like creating a lock on the data that we're trying to interact with. It's like they say, it's like calling open when dealing with text files. The open call itself doesn't really open the data, but it does access the data. And then we can use specific commands to interact with that data. Suri says, because you only have one table, you don't need a primary or foreign key. Not necessarily. There could be reasons why you still want a primary key for a single table, but we're going to talk about keys a little bit later on. We will talk about those in a minute. So once we have the cursor, we can begin to execute commands on the contents of the database using the execute method. So we can see here that we're calling execute each time to run individual statements. Each time we're going to call execute, and that's going to run the statement that we specify. Because everything sort of everything within the single quotes here, that's all SQL. Everything outside of the single quotes is Python. So essentially we're just executing SQL statements with a Python wrapper. So what this is here in the quotes is not Python, it's pure SQL, but we can wrap it in Python to control when and how it's executed. So as we'll see in a minute, I'll do this a little bit later, but we don't need Python to execute SQL. If we're using this like DB browser here, we can execute SQL directly. However, if we're doing it from within a program, whether it's Python or JavaScript or whatever, we need this sort of Python wrapper to tell the SQL when to run. Okay. So, and that's essentially what it's saying here. Database commands are expressed in a special language that has been standardized across many different database vendors to allow us to learn a single database language. As I mentioned before, it's like English. It's a single language that has multiple different dialects and variations. But in the end, if you know one version, you can probably learn any of the others fairly quickly. The database language is called Structured Query Language, or SQL for short. You may also hear it called SQL, but most folks are going to say it as SQL. In our example, we're executing two SQL commands in our database. Command 1, right here, and Command 2. As a convention, we'll show the SQL keywords in uppercase, and the parts of the command that we're adding, such as the table and column names, will be shown in lowercase. This is not required. It's more of just a language convention. You know, it's more of just a suggestion. You could write your SQL in all uppercase or all lowercase. Most of the time, it's going to be fine. Compilers are pretty good at handling it, but you know, just follow the convention and you'll be okay. Your English is sufficient. All right, so the first SQL command removes the track table, and then the pattern is simply to allow us to run the same program to create the track table over and over again without causing an error. Note that the drop table command deletes the table and all of its contents from the database. So remember how I said earlier that with great power comes great responsibility? You can do a lot of great and terrible things very quickly with SQL. So be careful. Because something like drop, there is no undo. Something like drop table is going to delete the entire table. Even if it has 1,000,000 rows, it's gone. So just keep that in mind. Rename the table instead. Yeah. So even if this table had 1,000,000 records, calling drop table against it is going to delete the entire table. Little Bobby drop table. Yeah. As a newbie, may I ask why? Why what? I'm sorry, I missed the... what is the why that you'd like more explanation? I'm happy to give more explanation. I'm just not quite sure what you're referring to. Oh, why is it deletes it right away? That's just how it works. SQL is a very direct language, I guess I should say. You're talking directly to the database. And so there are certain operations that are very, it's a very quick and efficient way to interact with the database, and that includes performing potentially destructive operations. Now, many programs like similar to DB browser, Microsoft SQL Server, the software that you use to write SQL and interact with the database, many of them will give you a warning and say, are you sure you want to do this? So for example, in Supabase, which has a SQL editor, Supabase is like a cloud storage relational database tool. It will ask you and say, hey, you're about to do something potentially stupid or silly. Are you sure you want to do this? And it will make you confirm before it will execute the command. However, raw SQL doesn't care. You can be as destructive as you want, as quickly as you want, and it's going to do it. Yeah, so generally dropping tables is not something you want to do unless you are in a dev environment or a learning environment. Yeah. So the second command creates a table called track, which we talked about, with a text column named title and an integer column named plays. So now that we've created our table structure, we can put some records or data into that table using the insert operation. So we're kind of doing we're going through the CRUD speed run here a little bit. We've done a delete operation. We've done a create operation. And we could call this maybe an update operation or a create operation, depending on how you're looking at it. So we're going to put some data into the table using insert. Again, it's just another statement. We're going to make a connection to the database and obtain the cursor, and then we're going to execute SQL commands. The insert command indicates which table we're using and then defines a new row by listing the fields we want to include, followed by the values we want placed in the new row. We're going to specify the values as question marks to indicate that the actual values are passed in as a tuple as the second parameter to the execute call. Okay, we're going to go through this a little bit more slowly. That's a lot. So let's just go ahead and do it. So we're going to say, call this SQL insert.py, and we'll talk through what is happening here. And then I'll show you what that did in the database. Okay. Once again, we're importing SQLite. And we're creating our connection to the same database. We're getting our cursor. And then we're going to execute a couple of different commands. So for each record that you want to insert into the database or into the table, you're going to need to execute a separate insert command for each record. So insert into track, which is our table, and we're inserting values for these two columns, title and plays. Now, these are the only columns that are in our table, right? Our table only has two columns, but could be times when you may not want to insert a record for each column. Let's say that, again, back to the cash register example. Let's say that, maybe providing my name at the cash register is optional and I don't want to give my name. So the only thing that cashier knows about me is the items that I bought, the amount, and the time that I bought them. I didn't give my name. And so I could specify that we only want to insert a record here for, amount, total, and time. We want to ignore the name column entirely. There will be no value in that column. So we're specifying that we want to insert records for these two columns, and then we specify the actual values that we want to insert in that same order. So title first, followed by number of plays, separated by columns. Matthias says it's still Python though, right? No, this is SQL here. This is SQL. It's just doing a little bit of a funky thing where for some reason it's storing the values in a tuple here, and then it's gonna substitute these into this here. So if I was writing a normal insert statement, I honestly don't know why they did it this way. For the very first time you're seeing an insert statement. If I was writing a pure insert statement, I would do it like this. I would do it like that. I mean, I know that, there's some formatting problems there, but this is how an insert statement should look. Say insert into table for these two columns, these specific values. Yeah, and I know that there's, you can protect against SQL injection and stuff, but if we're just trying to learn SQL here, this is really the basic SQL format that you'd be using. Yeah. And then for the second record that we want to insert, for these two columns, we want to insert these two values. And notice here the commit at the end. So we're executing two statements, and then we have this commit. And so we'll talk about this in a little bit, but just remember that, hey, this is a little bit different, right? We're executing these two things, and then we have to do this separate action that's a commit. Wonder what that's about. Now, what are we doing next? Well, we're saying print the word track, and then we're going to execute another command. We're going to say select title, comma, plays from track. So chat, what do we think this is doing? What do we think this is doing? Select title, comma, plays from track. Any guesses? It is grabbing some stuff, brings the values, getting those two columns. Yeah, it's basically doing a read, right? We're selecting all of the data in these two columns from the track table. So we've inserted a couple of records into the table. And then I'm going to execute this select statement to read those records back from the table and print them. So with this information that we have here, how many records will this how many records will this statement return? How many rows will this statement return? What do we think? We have 1, we have 2. We're going to test this in just a minute. I'm going to actually run this statement in just a minute. So we'll get to test this theory and see what we get back. Any other guesses? If I insert these records and then I run this select, no idea? Okay, that's fine. 2, if the screen reflects the entire table contents. Okay, yeah, let's see. So we're doing an insert, and then we're doing a read back from the table. And then this next statement here is doing a delete. I'm going to comment out this delete for now, because what this is doing is it's essentially going to delete everything that's in the table. And we don't want to do that because I want to show you what's in the table. So I'm going to comment this out for a second. And we're going to save it. And then after we've looked at what's in the table and seen what comes back, then I'll run the delete and we'll show you what that does. All right. And then we're going to do a commit, which we'll talk about in a second, and then close. All right, save. Py SQL insert.py. All right, we'll run this. Okay, so it's done the insert, and then it's done a read back from the table. So how many records did we get back, chat? How many records did we get back? We got 2. Yeah, we got 2 records back from the table because that's how many we inserted. So if we read everything back from the table, we've gotten 2 records. And I'm going to show you, I'm going to run this same statement directly in SQL. So I'm going to go into my DB browser here, and I'm just going to go into the raw SQL window here. So if I paste in this statement, I know it's really small. Let me make it bigger. There we go. I've pasted in the same statement. I'm going to uncomment it. I say select title, comma, plays from track, and I'm just going to run this raw statement. And there we go. I get the same answer. I get 2 records back, Thunderstruck and My Way. Now, since I'm essentially selecting everything in this table, because the table only contains the columns title and plays, what's another way I could write this statement that would do the same thing? If I want to say select everything from this table, what's another way I could write this statement? Yeah, I could also just say select star. Give me everything from the track table. Give me all the columns, give me all the rows. All right. And now I'm going to run this again. And it gives me the exact same answer. So we've inserted 2 records and we're reading back 2 records. Now I'm going to run the last part of this, which is the delete statement. So I'm not going to run it directly because I don't want to reinsert these records. So I'm just going to grab this delete statement, post it in here, and say delete from the track table where plays are less than 100. So what do we think this is going to do, chat? Delete from track where plays less than 100. Thank you for the follow, Extraordinario7. Delete from track where plays less than 100. Oh my goodness, Inu, thank you so much for the raid. Wow. Hello. Welcome, folks. Bye, Inu. Thanks for the raid. Yeah, Python. We're doing a mixture of Python and SQL today, folks. So if you like either one of those things, please do stick around. Hey, RDZ. Hey, Fabio. Yeah, so this statement is essentially just going to delete from the track table, delete any rows from the track table where plays are less than 100. Hey, IMV. Hey, Claudio. Welcome. What were y'all working on? Ardizio. Emil. Welcome. Thanks again for the raid, folks. So if I run this statement, how many records is it going to delete? We have 2 records in the table now. First one is Thunderstruck with 20 plays. Second one is My Way with 15. So if I run this statement, yeah, it's going to delete all of them, right? Because all of them have plays less than 100. Yeah. Peak and Flow, thank you so much for the follow. Claudio, thank you for the follow. Good to have you here. Sorry, my notifications are just catching up. Ardizio, thank you for the follow. Thank you all so much. All right, if you're interested in Python and or SQL, please do stick around. I have a lot of fun with SQL and I really like databases, so I get excited about this stuff. Alrighty. So that's essentially what we're doing here. We are inserting 2 records. We're reading those records from the database that we just inserted, and then we're deleting the records. Now, we talked a little bit earlier about delete statements. You can kind of maybe see why these could be dangerous, right? If let's say that I had 1 million records in my table, I could potentially delete all of those records if I didn't have a well-constructed where clause. So again, anytime you want to drop a table or delete records, just be very careful before you do so that your query is well constructed, because you could potentially destroy data that you don't mean to. Yeah. And Drips and Castle, thank you so much for the follow. Yep, especially if you forget to add a condition or if it's poorly written, 100%. So again, going over it one more time, we insert 2 rows into our table and we use commit to force the data to be written to the database file. So you can think of commit. You can think of commit as sort of like save. Or if, let's say, if you're all familiar with Git, I'm sure most of us here, we've used Git at one point. If you are trying to commit something to your database repository, it's essentially the same thing. The first thing that you do is you use add to stage the files, right? You call add, and that stages the files that you eventually want to commit, but you haven't committed them yet. You've just staged them using add. And that lets you kind of take a look and be like, oh yeah, I think these are all the files that I wanted to commit. This is a good final list. I'm happy with this. And then the final action that you do to complete that process is you commit them. And you're doing essentially the same thing with SQL. Is you're starting that transaction, you're performing the operation, you're making sure that it's correct, and then when you're happy with it, you're going to commit, and essentially that's your point of no return. You're once you've done it, you've done it. Matthias says, is where like when? Sort of. It's a condition, right? It's almost like an if statement. You're essentially saying like, hey, if this condition is true, then perform this action. So looking at each record, for each record where this condition is true, then perform this action. So you can maybe think of it that way. Peak and Flow, welcome. They say, is that just for SQLite, or do you need to commit for MySQL, SQL Server? Yeah, so transactions are kind of a common thing that you can use in almost any flavor of SQL. Now, depending on your implementation, you might have it set where transactions are auto-committed. So you might not know that those transactions are happening unless, a lot of times that's a setting you can configure in your particular SQL client. But transactions are good to have if you're doing potentially complicated or destructive operations. Yeah. So with Python, we have to call commit before before these operations are finalized, I guess. So for example, before this delete is truly final, we have to commit. So that can give you, especially if you're writing raw SQL in like a SQL client, that can give you a lot of leeway in terms of validating your work first. You can check that operation locally and then be like, yep, that did exactly what I expected. Or it's going to say, for example, a lot of times when you run an operation, it's going to say something like 100 rows affected or 5,000 rows affected. And you might be like, 5,000? That's not what I wanted. That's way too many records. I did something wrong. And then you can roll back that transaction and it'll be like nothing happened. So there's your undo. Okay. So after we do our insert, we do our select command to retrieve the rows we just inserted from the table. On the select command, we indicate which columns we would like and indicate which table we want to receive the data from. After we execute the select, the cursor is something we can loop through in a for statement. For efficiency, the cursor does not read all the data from the database when we execute the select statement. Instead, the data is read on demand as we loop through the rows in the for statement. So, for example, essentially what all that's saying is that it's going to just read through each record and it's going to retrieve the ones that match the criteria and return those records. Our for loop finds two rows, and each row is a Python tuple with the first value as the title and the second value as the number of plays. At the very end of the program, we execute a SQL command to delete the rows we've just created so that we can run the program over and over. The delete command shows the use of a where clause that allows us to express a selection criterion so that we can ask the database to apply the command to only the rows that match the criterion. So I said it's almost like an if statement or a filter. In this example, the criterion happens to apply to all the rows, so we empty the table out. So that's an important distinction. That's the difference between a delete and a drop table. With a delete statement, we're only deleting the records. The table structure is still there. So if I run this delete statement and I go back to my database structure here, actually I'll do another select here. we can see that the table structure is still there. The columns are still there, but the data is gone. So a delete is only going to get rid of records. A drop table is going to get rid of the entire table and all the contained records. Okay? After the delete is performed, we can also call commit to force the data to be removed. Thank you for the follow, Sociopath Chick, Eduardo, and Palo40. Thank you so much. Good to have you folks here. So far, we've been using the structured query language in our Python examples and have covered many of the basics of SQL commands. But let's look at the SQL language in more detail and give an overview of SQL syntax. So since there's so many different database vendors, SQL was standardized so we could communicate in a portable manner to database systems from multiple vendors. And that's true. No matter whether you have an Oracle database, a Microsoft database, a Postgres database, and really any relational database client that you use, like Supabase or, a local database on your machine, you can use SQL to talk to them. So a relational database is made up of tables, rows, and columns, and the columns generally have a type such as text, numeric, or date. When we create a table, we indicate the names and the types of the columns. So that's what we saw earlier, right? We have two columns, one called title with a type of text, and one called plays with a type of integer. To insert a row into a table, we call the insert command. So here's the more compact version of that insert command. So we just say insert into our table name, the columns we're inserting into, and the specific values for that column. So notice that the title, the column name, and the value for that column are in the same order, right? I need to put the title with the title and the plays with the plays in a comma separated list. So if they're not in the same order, you can end up inserting data into the wrong column. This can get a little bit tricky when you're dealing with a table with a lot of columns. So if your table has 100 columns and you're trying to write an insert statement, things can get a little wild. No worries, Matthias. Good to have you here. Maiva says, so we can override? What do you mean by override, Maiva? What would you like to override? We specified the table name. Feel free to, I would like to answer your question. I just don't quite understand it. The insert statement specifies the table name, then a list of the fields and columns that we'd like to set in the new row, and then the keyword values and the list of corresponding values for each of the fields. So the select is like our read statement. That's what we use to retrieve rows and columns from the database. The select statement lets you specify which columns you would like to retrieve, as well as a where clause to select which rows you would like to see. It also allows an optional order by clause to control the sorting of the returned rows. Okay, let's do that really quickly. So I'm going to run these inserts again, just so we have data back in our table because we just deleted it. So let's run this one more time. Nope. Let's see. What did I do? Oh, database is locked. Because I currently have so that's actually I like this. This is great. It says operational error, database is locked. Now, why would it be locked? Well, because I currently have an open connection in my SQL browser here that is trying to read from this table. So I'm going to close this. Let's discard. There we go. So that's a data protection measure to show that, hey, if I am currently modifying this table, don't let anybody else modify it. That's a little bit of database protection there. Oh, hey, Extraordinary. Welcome to the stream. They say, is there a Discord link? I personally don't have a Discord, but I am associated with the 100 Devs nonprofit group, and they do have a Discord. So if you'd like to check that out, you can do !100 devs, !100 devs, I think, and I can do it for you. I think that's the command. There you go. So that'll take you to the website, and then there's a link you can click on the website where there's an invite for the Discord. Of course, Extraordinary. Thanks for being here. All right, let's try that again. I might still have a lock. I might need to actually close this. Yeah, we'll close this for now. Oops. Yeah, there we go. And so notice as soon as I close the browser, it let me do it. All right, now I want to actually do a select statement. So let's modify this script to just do a select statement, and we're going to do a we'll do a where clause on it. So connect, get the cursor, and we'll just say give all this. Actually, I'll probably do double quotes here. Go. So if I run this SQL statement, how many records do you think I'm going to get back? Yeah, I may have inserted them twice. Let's run that in the browser. It'll be a little bit easier to see. So yeah, that could be a trick question, unintentional trick question. We'll open it here. It's just a lot easier to see in the plain browser. I don't mean to trick you, so that's why we're going to look at it in here. So we'll run this statement in here. Okay, yeah. So if I browse the data, we can see that I inserted the rows twice. I inserted the rows twice. And so if I were to run a select statement on this table as it is formatted right now, I would get back 2 records, right? Yeah, the answer is 2 rows. I'd get back both of these rows that have the value of my way. So let's just run that real quick just for funsies. So we'll say, do this and run that. Yeah, so I get back 2 rows, right? Answer is 2 rows. Both of them for my way. Yeah, well, we are going to talk about normalization in a minute, so I'm going to kind of leave this the way it is. And notice that we're doing select star here, right? We're doing select star, and it's essentially just retrieving everything. But the where clause filters the amount of records. So by saying select star, we're retrieving all the columns, but the where clause is going to filter the rows based on their values. So this tells us the columns we want to retrieve, and the where clause filters on the rows based on their values. Killer says, is there a way to remove duplications? Yes, that's a little bit beyond the scope of of what we're going to talk about today. But yeah, you can absolutely clean data in various ways. And you can use, if you are potentially going to have duplicates in your database, there's ways you can control for that. You can prevent those duplicates from ever being written in the first place. That's really what you want to do, is format your table in such a way to prevent duplicates from being written. And we're going to talk about that in just a minute. So using star indicates that you want the database to return all the columns for each row that matches the where clause. Unlike Python, in SQL where clause, we use a single equal sign to indicate a test for equality rather than a double equal sign. And that's a really great point. I didn't even notice that just because I'm so familiar with SQL. But yes, in SQL, a single equal sign is not an assignment. It is a true check for equality. So just keep that in mind. Other logical operations allowed in a where clause include all the standard ones, less than, greater than, less than or equal to, greater than or equal to, not equals, as well as and or, and parentheses, etc. So really any kind of comparison that you could do in Python or JavaScript, whether it's with strings or with numbers, you can also do in a where clause. So even if you don't quite know the syntax, you can be like, yeah, I want to do like this comparison. I want to check if a string is in a list or if a string contains certain values. You can use regex. You can check against a list. You can do math. Really, any type of comparison that you could do in another language, you can do in SQL. We can also request that returned rows be sorted by one of the fields as followed. So we can select those columns from our table and order by a specific column. So if we do that really quickly, we're going to select both columns from track, order by title. So when I do that, it's going to sort the results, and that's really small text. I want that to be bigger. Sorry, 1 second. Results font size is set to 12. Make that bigger. Set it to like 18. Okay, that's the results down there. Okay, sorry, hang on. Just making all the fonts bigger. There we go, that's better. Okay. So here we can see that it's sorted them in alphabetical order, right? So we can order by, and I could also order by plays instead. And when I do that, actually when I do that, I'm actually going to get the same result because it's going to sort smallest to largest. But what if I wanted to order it in the opposite direction? So this is ordered in ascending order, right? And don't think about it too hard. What if I wanted to order in the opposite direction? If I wanted to do the opposite of ascending, what would I specify? Instead, M Marvel says descending, and Null Recall says descending. Yeah. So this is ordered ascending. If I wanted to order in the opposite direction, I would just say it's, again, like I said, don't think about it too hard. I just say order by descending. Ta-da! And that orders it the opposite way. Yes. So ascending is the default. I can specify ascending if I want to, and that's fine. It'll do the same thing. You can see, order it in ascending, and then just reverse it if I want to go the opposite direction. Yeah. So like I said, SQL is meant to be a very friendly language. It's meant to use words that you already know to define interactions. So all these are common English words that you already know. And really the main challenge is just knowing what order to put the words in. Because sometimes they're a little bit different than like a standard sentence, right? But once you know the order to put the words in, you can usually guess as to the right words to use to get what you want. Code Writer says it looks kind of like COBOL. Yes, it absolutely does, because it's a similar vintage to COBOL. It's not quite as old as COBOL is, but SQL was invented in 1977. And the original, like the SQL as we know it today, was invented in 1977. The original idea for the language was from the early 70s. So it is very similar to COBOL because it's of a similar era of COBOL. Although the main difference is that SQL is still very widely used today, whereas COBOL is still used but less common. Skinny Kenneth, thank you so much for the follow. Marvel says SQL is easy in the early and simple data querying. Yes. And for the most part, that is all you all will need to know. Unless you plan to become a SQL developer or a data engineer, you're going to be just fine with knowing simple queries, knowing basic select statements, knowing basic inserts, updates, joins, and you might not even need those. Most people only ever need to know how to do a select statement and maybe a couple joins. Now, just like with any language, you can get real weird with it. You can do a lot of crazy stuff and a lot of really complex stuff. But the majority of people are only ever going to need to know how to write a select statement. Null says, bonus question, what was the first database to use SQL? Yeah, I'm sure I've read it at one point and I don't remember. So if you know, please tell me. All right. System R, IBM System R. Okay, very cool. All right, so we can order in a certain order, and we can also update an existing column. So Maiva, this might have been what you were asking about before. Can we do an override? And yeah, we can. We can instead of having to delete a row and like reinsert it every single time, we can also do an update, because remember, we can do full CRUD operations against a database with SQL. So part of the CRUD acronym is updates, right? So if we want to do an update, we can create an update statement. And within this update statement, we can update one or more rows. So I could update multiple rows simultaneously. Like I could update every single row in a table to a specific time or have a specific name or a value. But most of the time, I'm going to only want to update a single row or a group of rows that meet the criteria in my where clause. So once again, the where clause is going to come in clutch. Whenever possible, whenever you're working with real data, whether you're doing a select statement or you're doing an update statement or a delete statement, you should always have a where clause. So just keep that in mind. Whenever you're working with real data from a real table, you're pretty much always going to want to add a where clause to filter the data down to only what you need. For a select statement, where clauses are great because you can only return the data you care about. So if I want to only look at transactions from the past week, I could do a where clause that says, only give me transactions from the past week. Don't give me transactions from the past 10 years, right? Or if I'm doing an update statement, right? Let's say that my name is spelled wrong in a database and it's in there 200 times. I could say update this table, set name equals Mayan Wolf, where name is, I don't know, Maya Wolf, right? If it's wrong, I can simultaneously update every instance of that incorrect name. Especially with deletes, you absolutely should always have a where clause. Maybe I only want to delete records that were entered with a date of February 31st, right? That doesn't exist. Those records aren't valid. I want to delete them. So only delete records from this table that have a date of February 31st. And I would use a where clause to do all of those things. Yeah. Marvel says, yes, you are right, but if you know a little more, like count and add some calculated columns, you can simplify some code stuff. Absolutely, yes. So it's really up to you how far you want to go with SQL. As you kind of start learning like select statements and stuff like that, you'll eventually start to think, gosh, I wish I could, pre-summarize some of this stuff before I get it in my results. And then you'll find, oh yeah, it looks like there's a way I can do that. And so you kind of start to branch out organically from the basic stuff. Anyway, we can update. And when we update, we can use a where clause. The update statement specifies the table and the list of fields after the set keyword, and then an optional where clause. I would say it's not optional. You should always have one. To select the rows that are to be updated. A single update statement will change all of the rows that match the where clause. That's why you should always use a where clause. If a where clause is not specified, it performs the updates on all rows of the table. Don't do that. So to remove a row, you need a where clause on a SQL delete statement, just like I just mentioned. The where clause determines which rows are to be deleted. Delete from track, where title equals my way. So if I were to run that delete statement, delete from track, where title equals my way, it would delete this record and this record, because both of those have a title equal to my way. So these 4 basic SQL commands, insert, select, update, and delete, will allow the 4 basic operations needed to create and maintain data. we use CRUD, create, read, update, and delete, to capture all these concepts in a single term. We all know CRUD, right? Y'all have heard CRUD? Yeah. So that's how you do those in SQL. And I will say that if you're just working with data from like an analytics perspective, like if you're just trying to retrieve some data to analyze, most of the time you will only be doing this. If you're working with somebody else's data, you will often only be given read-only permissions for that data. A good database administrator will only give you read-only permissions. You will never have the ability to do these things for data analytics purposes. Now, if you're building like a web application or something like that, you will often be, doing all four things, or at least these three: insert, select, and update. But if you're just doing data analytics, most of the time you'll only be doing selects just to read the data. So a good database administrator will determine the privilege level you're allowed to have, and those are the only types of commands you'll be able to run. Hey, Jesus, thank you so much for the follow. All right, so somebody asked earlier, what about duplicates? How do we handle duplicate values? Or, what do we do if you have the same value entered over and over and over in a column? How can we reduce the size of our data? And that comes down to multiple tables and data modeling. So the real power of a relational database is when we create multiple tables and we make links between those tables. That's why it's called a relational database, because the tables relate to each other. So the act of deciding how to break up your application into multiple tables and establishing the relationships is called data modeling. The design document that shows the tables and their relationships is called a data model. Data modeling is a relatively sophisticated skill, and we will only introduce the most basic concepts of relational data modeling in this section. Yeah, there's people called architects or data architects that is their job. Like on the team that I work with for work, we have somebody who that is her job, is she is the architect, and she figures out how all this data should be modeled out. So I don't have to worry about that. I only have to worry about, getting the data where it should be, and then she's going to figure out the actual structure that we're working with. Oh, thank you for the stretch. There we go. All right, let's say for our tracks database, we wanted to track the name of the artist for each track in addition to the title and number of plays. A simple approach might be to simply add another column to the database called artist and put the name of the artist in the column as follow. So let's do that. We're going to run this real quick. We're going to drop our existing table and then recreate the table with 3 columns. Title, plays, and artist. Now, before you ask, yes, there is a way to add a column to a table without dropping it first. That's absolutely something you can do. In this case, I think they're just dropping the table and recreating it so that we have a clean slate to work from. But you can absolutely call add column and add a column, a new empty column to an existing table. That's something you can do. In this case, they're just choosing not to. So we'll go ahead and do that. Architect sounds like such a fancy title. Yeah, it is. I mean, it takes a lot of skill, especially when you get into like enterprise level databases. Things can get real complicated. All right, so we're going to drop the table if it exists, and then we're going to create a new table with these 3 columns. There we go. And then we're going to insert a couple of tracks into our table. So we're going to insert all of these. Oops. Oh, I didn't copy the I in insert. There we go. Okay, so now if I do a select against this table, select star from track. Now we can see that I have 3 columns, and the artist for both records in this table is Frank Sinatra. Okay? So if we do a select star from track, we've done a fine job. Yeah, we can see that those 2 records are there. However, this is not necessarily best practice from a data modeling perspective. Because technically, we're duplicating data, right? I wouldn't say it's a very bad error. I disagree with this personally, but I would say it's maybe not best practice depending on how you're planning to use your data. We violated the rules of database normalization. So, what is one simple rule that we can follow? We should never put the same string data into a column more than once. If we need the data more than once, we can create a numeric key for the data and reference the actual data using this key, especially if multiple entries refer to the same object. So, as an example, what we're going to do is almost create like a lookup or like a reference. So instead of writing the value to the table directly, we're going to reference another table which only contains that value once, but references the location of that value in the table. So we'll see that in action in just a second. But essentially, instead of having Frank Sinatra, Frank Sinatra, Frank Sinatra, a dozen times, we're going to have it in another table once, and we're going to look up against that table a dozen times. Correct. We're going to create a new table with the artist and use their reference ID as a key. So you can see here what's happening is, what if we wanted to also keep track of the eye color of our artist? So we're duplicating even more data here. We're inserting Frank Sinatra and blue, Frank Sinatra and blue. So things can get really complicated if you have multiple duplicate records and you're trying to keep them all in sync. Why not just have one reference table which contains all the values associated with Frank Sinatra, his eye color, his height, his hair color, all those things, and then we can just reference that information whenever we need it. Thank you so much for the follow, Odd Basil. Yeah, and that's a great point. So Peak and Flow gives a real example there. They say, at my job, we have a non-normalized database, meaning that there's a ton of duplicate data everywhere. So everything is just entered raw into the tables. So they say, if you want to change a client phone number, you would need to change it in a dozen different tables rather than just having a lookup table of phone numbers and having every other table look up the client phone number from that table. Yeah, so that's a real valid example of that happening. Since Frank Sinatra recorded over 1,200 songs, are we really going to put his name and the string blue in 1,200 rows in our track table? What would happen if we decided his eye color was light blue? That's exactly what Peak and Flow is saying. What if we decided that we wanted to change this value? We'd have to update 1,200 rows, and that would suck. The correct solution is to create a table for each artist and store all the data about the artist in that table in one record. And then somehow we need to make a connection between a row in the track table to a row in the artist table. Perhaps we could call this link between two tables a relationship. And that is exactly what database experts decided to call these links. So we're going to make a new table. We're going to create a new table called artist. It's going to have two columns, name and eye color. And then we're going to insert one record for Frank Sinatra. And we have a new table called artist. It's got one record for Frank Sinatra. Oh my goodness, extraordinary. Thank you so much. I'm glad you like my teaching. Yeah, it's a lot of fun for me to do. And if you're interested in some of my other videos, I normally teach full stack web development. So if you're interested in some of that, I have a YouTube archive with like 2 years worth of videos at this point. So you're welcome to check that out. It's ad free. You can do !YouTube to get a link to that channel. Oh, thank you, Skinny Kenneth. But yeah, I've got like a 2-year archive at this point, ad free on YouTube if you want to check any of those out. Hey, Iced Fire. Yeah, we're doing SQL today and Python. Python and SQL at the same time. It's wild. All right, so now we have this reference table, right? So we have a row in the table for Frank Sinatra and the eye color and a primary key of 42 to use to link our tracks to him. So we're going to alter our track table as follows. All right. So let's run this, and then we'll talk about what it's doing. We're going to drop the track table again, and we're going to recreate it instead of programming Frank Sinatra and Blue 1,200 times, we can simply reference the location in that other table. So the artist ID column is an integer, and by naming convention is a foreign key pointing at the primary key in the artist table. And you might be like, okay, why do I care? What did that change? It's still two separate tables. Yeah, it's maybe like one less bit of strings to write, but what did that do? What did that do for us? Well, here is the magic. Here is where the relational part of relational databases actually comes into play. We have established the relationship. We have established that each record in our track table has a value of 42 for the artist ID, and the artist in our artist table has an ID of 42. So with those two together, we can create what's called a join. We can literally join this data together and get a combined result with exactly the data that we want. So let's see how to do that. We're following the rules of database normalization, but when we want to get data out of our database, we don't want to just see the 42. We want to see the name and the eye color of the artist. To do this, we introduce a new keyword called join, because we are literally joining those two tables together. So let's see what happens when we do this. I'm going to select title, plays, name, and eyes. Now you might be saying, wait, hang on. But the track table doesn't have name and eyes as columns. It only has title, plays, and artist ID. So how does this work? Well, we're saying select all these things from the track table and join the artist table to it. So now we have access to all the columns in both tables. So we can join these two together on that key field that we created. It's a common field between both tables. Join by ID, exactly. Because the common field between both tables is the artist ID. Suri says join is like saying from X and Y. Exactly. So we're specifying the two tables to join together and their common element. So we know how to fasten those records together to get exactly the data that we want. So let's slow this down a little bit. I'm going to do a select from track just to show you what's in there. Because this can be really hard to visualize the first time you see it. So select from track. I've got title, plays, and artist ID. This is our common element, artist ID. Now I'm going to select track from artist. And we can see that that's Frank Sinatra and Blue. And actually, did I not have the ID in there? Did I do that wrong? Hang on. We'll just run that again. I might have just accidentally blanked out the first thing. Okay, let's do another select there. Artist. There we go. Okay, so artist has 42, Frank Sinatra, and Blue. The common field between them is this ID value. So now let's do the join. Select title, plays, name, and eyes from track and join to it the artist table on the artist ID value to the ID value in the artist table. So for every record in track that has an artist ID of 42, it's going to look at the artist table and say, hey, here's a value of 42. I can match this data to the record in track. Whoa, right? That's wild. Hey, Melon Pan, welcome to the stream. All right, so let's actually run this, and then we'll see what happens with the select statement. So check it out. Now, in our results, we have a combination of the data from both tables. So even though there's only one record in the artist table, we can reference it as many times as we need to in our statement. That's how we can normalize our data, or we can reduce its size, right? So even though I could have a million records for songs by Frank Sinatra, I only need one record in the artist table and I can just reference it a million times. Exactly. You can have many results to one item, thus saving space throughout the database. Yes. It's sort of like why we build functions, right? Why do you build functions in JavaScript or Python? You have an action that you want to repeat over and over and over again, and you don't want to code it out every single time you need it. So instead, what you do is you build a function that you just reference over and over and over again. There's only one instance of that function. There's only one definition of that function. You just reference it as many times as you need it. And that's what we're doing here. Skinny says, does it get very complicated to use multiple relational DBs? It can, depending on how big your data is. That's why in most corporations, you have a database architect whose entire job is to think about this stuff. To think about, is it going to be more efficient to create a separate table? What records should be in that table? How should that table look? How many separate tables do I need? That's a whole job for some people. So it just depends on the size of your data. But anyway, that's how joins work. Oh, thank you for the stretch, by the way. So the join clause includes this on condition that defines how the rows are to be connected. For each row in track, add the data from artist from the row where artist ID track table matches the ID from the artist table. Well, it might seem a little clunky, and your instincts might tell you it would be faster to just keep the data in one table. It turns out that the limit on database performance is how much data needs to be scanned when retrieving a query. While the details are very complex, integers are a lot smaller than strings and far quicker to move and compare. This is very important. So if you are building a production application, especially one where users are interacting with it, a lot of the times you're going to be working with a lot of strings, a lot of text. You're going to be storing a lot of text. You're going to be storing people's names. You're going to be storing, like someone mentioned earlier, you're going to be storing phone numbers, addresses, lots of long strings. Whenever possible, you're not going to want to duplicate that information. You're going to want to store that in some kind of a reference table and then look it up using integers, because integers are much faster in databases than strings are. That's just the way they work. You can look up an integer a lot quicker than you can process a big long string. So that's probably if you're going to remember nothing else about database normalization, remember that. Whenever possible, try not to duplicate strings, because if your table gets into the millions of records, you're going to see major slowdowns in performance when you're trying to access that data. So try to avoid it if you can. Because I know some of you are, web developers, or you're building, real apps for clients. And so that's an aspect of database design that you absolutely should keep in mind if you're seeing slow performance from your data. Are you using a crap ton of strings? If so, figure out a way to normalize that so you can use fewer strings. All right, talking briefly about data model diagrams. This is probably not something you're going to need to care about too much, especially if you're not an architect, but it's still reasonable to go over it. So our track and artist database design is simple, with just two tables and a single one-to-many relationship. These data models can get complicated quickly, and they're easier to understand if we can make a graphical representation of our data model. So, a verbose one-to-many data model. While there are many graphical representations of data models, we'll use the classic approaches like a crow's foot diagram, and this is what you'll most commonly see if you're looking at a database design. Each table is shown as a box with the name of the table and its columns. This is where where there is a relationship between two tables, a line is drawn connecting the tables with a notation added to the end of each line indicating the nature of the relationship. So for our two tables here, the first one is called track. The table name is always first. So the table name is always the first line, track, and then the columns are listed vertically below it. So from track, we could have many records that relate to one artist, right? We could have 1 million records by Frank Sinatra, and it's only going to map to one record in our artist table. So many records to one artist. In this case, many tracks can be associated with each artist, so the track end is shown with the crow's foot spread out, indicating it is the many end. That's the crow's foot there. I have heard of Exopunk, Vay. Yeah, absolutely. Welcome to the stream, by the way. Yeah, I've heard of Exopunk. I haven't really played it, but I have heard of it. There are some fun scripting games out there. The artist end is shown with a vertical I think he means line there, vertical line that indicates one. There will be many artists in general, but the important aspect is that for each artist, there will be many tracks, and each of those artists may be associated with multiple tracks. You'll note that the column that holds the foreign key, like artist ID, is on the many end, and the primary key is on the one end. Okay, so let's talk about keys for a second. When we talked about keys before, right? And from your knowledge of, like, say, JavaScript objects or Python dictionaries, what is a key? You know the term key from, looking at Python dictionaries, JavaScript objects. What is a key? Yeah, a key is a unique identifier, right? And it means exactly the same thing in SQL. It means exactly the same thing in SQL. So the reason that we can do this join at all, the reason we can join to artist, is because every single artist record in the artist table has a unique ID. So when I say 42, it's always going to refer to Frank Sinatra. It's always going to refer to the Frank Sinatra record. So that is what's called a primary key for that table. For the artist table, the primary key, the unique identifier, is 42. There can never be another record for Frank Sinatra with the same value. This is the unique value for that record. So if I want to reference that key in another table, for example, if I want to reference that key in track, when I reference that key here, that's what's called a foreign key, because it references the primary key of another table. So here I can have multiple records with a value of 42 because I'm referencing that primary key over and over and over again. But it is still a key, so we call it a foreign key. It's looking elsewhere and identifying a primary key from another table. Okay? So that's what we mean when we say key. Primary key and foreign key. Primary key is the main unique identifier for a table. Foreign key is a reference to that primary key in another table. So in this case, we'll notice that the column that holds the foreign key, like artist ID, is on the many end because we're making multiple references to that primary key. That's the many. The primary key is on the one end because we can only have one record with that key. Since the pattern of foreign and primary key placement is so consistent and follows the many and one ends of the line, we never include either the primary or foreign key columns in our diagram of the data model as shown in the second diagram. The columns are thought of as implementation detail to capture the nature of the relationship and not an essential part of the data being modeled. I've seen this done. That's not necessarily a hard rule. I've seen it done where the keys are listed. I don't know. Some of the stuff that's being said here is not necessarily true in all cases. So just take that with a grain of salt. You may sometimes see keys listed in these entity relationship diagrams. So let's talk about primary keys. In the above example, we arbitrarily assigned Frank the primary key of 42. However, when we're inserting millions of rows, it is nice to have the database automatically generate the values for the ID column. We do this by declaring the ID column as a primary key and leave out the ID value when inserting the rows. Yeah, so let's do that and let's see what happens. Because fortunately, the database is smart enough to know what primary key means and that those values should be unique, and it can auto increment those primary keys as needed. So we're going to drop the artist table and we're going to recreate it with a primary key, a name, and eye color. But then when we do an insert, we're only going to insert values for name and eyes. We're leaving out ID. So let's do this. I'm going to run the statements individually. So first we're going to drop the table. And then we're going to create the table again. And then we're going to do an insert. Okay. So when I've done that, it did the insert even though we didn't specify a value for the ID column. So what happened? Let's see. What did it do? There's no error here. It was generated automatically. Yeah. Now, what would this do if I inserted a second record? What would my ID be? 2, right. It's going to auto increment. Unless we specifically specify an ID, it's going to auto increment that value for us because it understands that primary keys should always be unique. All right, here's a tougher question for you. What if I had 3 records in this table with IDs of 1, 2, and 3, and I deleted record 2? I said delete from artist where ID equals 2. What would my remaining IDs be? Yeah, they would be 1 and 3, and the next one would be 4. Why is that? Why, if I deleted the record with ID 2, why wouldn't it just create, a new value with ID of 2? It still increments, yes. And in a more fundamental sense, IDs, primary key values, are meant to be truly unique. So if anything was previously referencing that record with an ID of 2, if anything, elsewhere, let's say you have a join that was saying, hey, join where ID equals 2, and you've deleted that record, and it tries to create a whole new record with different information, but that ID of 2, you could end up retrieving data that you don't mean to. And so that unique ID, once it's assigned, it's always going to be unique to that record. Even if you delete it, then that ID is gone. Yeah. Okay, so it's auto-assigning. We've instructed the database to auto-assign us a unique value, but then we need a way to have the database tell us the ID value for the recently inserted row. Because if we're inserting, hundreds of records at a time, we might not necessarily know what ID we're trying to retrieve or what the last ID was. One way is to use a select statement to retrieve data from a SQLite function called last insert row ID. So we could do, if I just run this, select last insert row ID, it's going to tell us that the last inserted row ID was 1. If I had a dozen records in here, it would say last insert row ID is 12. Yeah. So there's built-in functions you can use that give us sort of like metadata about our tables as well. So rather than just retrieving records as they are, you can use additional functions like sums and counts, row IDs, that sort of thing, to retrieve more analytical data about your tables. And that's a great point. That's something I was going to mention as well. This syntax for this type of thing, as you get a little bit more complicated, it's often going to be different depending on which version of SQL you're using. So Google is your friend. You can just say, how do I get the last row ID in Postgres? How do I get the last inserted row ID in, Oracle, whatever. I wouldn't recommend memorizing these things. I would just have the knowledge that you can do them, that they are possible, and then Google them when you need them. So once we know the ID of our Frank Sinatra row, we can use it when we insert the tracks into the track table. And we can add these ID columns to any table that we create. So in this case, we're dropping the table if it exists. We're recreating the table track. We're adding IDs as unique values. And then we're linking it to the artist ID. So we'll do that. I'm just going to create a new tab for this. Okay, we've created the table structure. Oh, thank you, Extraordinary. I'm glad you like my videos. It's very nice of you. So now we're going to notice that we are also going to auto-generate IDs for the track table as well, because we've declared it as a primary key, and so it'll auto-increment as we go. So we're going to insert into each of them. And I know that they are, like, he's doing them directly in the SQLite command line interface here, but personally, I think it's easier for you to see what's going on if I execute it directly in the SQL browser. You can do SQLite from the command line, but it's going to be a little funkier. And if you're new to SQL, you might as well just run it in here. So that's why I'm getting rid of this formatting and all this stuff. I'm just running these straight in the DB browser. But as of Python 3.12, you can use SQLite directly in the command line. You don't have to install anything. It's built into Python. But I mean, if you have a browser like this, you might as well use it. All right, we're going to insert into track and insert both tracks. So now if I say select last insert row ID, we should see 2. Yeah. Marvel says, note if you do Control Enter, it runs and executes the line where the cursor is. Yes. Yeah, there's keyboard shortcuts that can help you execute things faster. And you can execute individual statements by highlighting them. So notice how I highlight this statement and it only runs this line. That can be really useful. If you want to go ahead and just draft multiple statements, but only one of them, you can just highlight it and run it. And okay, so looking more at keys. If we had a table full of artists and a table full of tracks, each with a foreign key link to a row in a table full of artists, and we wanted to link all the tracks that were sung by Frank Sinatra as follows, so basically the same join that we did before, we have 2 tables and a foreign key between the 2 tables. Our data is well modeled, but if we're going to have millions of records in the artist table and going to do a lot of lookups by artist name, we would benefit if we gave the database a hint about our extended use of the name column. We can do this by adding an index to a text column that we intend to use in where clauses. Yeah, so an index, thank you for the posture check and the hydrate. So an index essentially works the same as an index in a book. So what does an index in a book do, chat? If you open a book and it has an index, what does it do? Oh, no worries, Extraordinary. Yeah. It tells you where to find stuff, right? It points you to specific parts of the book. It tells you the exact pages where you can find specific phrases or concepts or whatever. And that's exactly what an index does in a database. So if you have a bajillion rows in a table, you can make the database create an index that it can use when it needs to find something. So it's essentially just an internal sort of a map to the data in your table that can make it a lot easier for the database to look that data up when it needs to find it. So it's essentially going to scan all the data, and it's going to say, this value is here, here, and here. This value is here, here, and here, et cetera, et cetera. And it's going to do that kind of mapping ahead of time. So then when you say, hey, give me all the records for Frank Sinatra, it can, instead of having to scan through every single record and try to find all the references to Frank Sinatra, it's going to go to the index and be like, okay, all the references to Frank Sinatra are here, here, and here. I'm only going to go to those locations, and that's the only records I need to look at. I don't need to look at a million records. I only need to look at the 500 records in these locations. Hey, Holly Luck, good to see you. So when the database has been told that an index is needed on a column, it stores extra information, just like an index in a book, to make it possible to look up a row more quickly using the indexed field. Once you request that an index be completed or created, there is nothing special that is needed in the SQL to access the table. Your SQL will not change at all. The index is just for the database to use for its own purposes. The database keeps the index up to date as data is inserted, deleted, and updated, and uses it automatically if it will increase the performance of a database query. You don't need to worry about the performance. It's going to use the index if it needs it. Text columns that are used to find rows based on some information in the real world, like the name of an artist, are called logical keys. And you might also hear them called like business keys, something like that. So we can also add constraints to our database as well. For example, we talked earlier about how do we, yes, you can eliminate duplicate records from your table, but it's much better if you just make it so you can't insert duplicates in the first place. And that's what you'll find most of the time. So when we define our table, we can also create a unique constraint so that if you try to enter a duplicate for a particular column, it's not going to let you do that. So again, this can be super useful for like full stack web applications. So if you're building full stack web applications and you want to say I'll ask you. If I'm building a full stack web app, what is a place where I want to be 100% sure that I have no duplicates in my database? What's a element of that web application where I want to be gosh darn sure that I have no duplicate values? Emails, absolutely. Email addresses for auth users, yep. Phone numbers, yeah. Logins, yeah, like usernames, right? If I have two users in my application, if I have two users with the same username, imagine the chaos, right? Imagine the potential chaos that could cause. Much less, sharing of personal data, people being able to access, sensitive stuff that isn't theirs. That's actually happened. I've seen real world incidents where that has happened, where people are allowed to access things that they do not own just because there was not good duplicate protection in the database. And so let's say you have two of the same username in the database, you do a select against that database, it's just going to return whatever the first matching record is for that username. It could be the right person, it could be the wrong person. You don't know. Yeah, passwords are going to be different generally because they're going to be encrypted, or they should be anyway. But especially for usernames, emails, phone numbers, personal details, that type of thing, you definitely want to not allow duplicates for that. Yep. So in order to do that, we can create a unique index on the column that we don't want to duplicate. So if we try to write a duplicate to that column, it will literally stop us. And we can tell the database to ignore any duplicate key errors, but I don't do that. I'm not even going to read this part. If a table has a unique constraint, you should abide by that constraint. You should not overwrite it. So we're going to skip that part. I don't know what's in here. Nope. Nope, nope. Skippy skip. That's the only part of this text I'm skipping. You can read it if you want. Don't do it. If a table has a unique constraint, that constraint is there for a reason and you should abide by it. So don't try to circumvent unique constraints. They're often vitally important for the data structure. We're gonna fail. Yeah. Now, yeah, passwords are kind of a different deal in terms of duplicates because often they're hashed, they're salted, they're you will in any database that is run by anybody remotely competent, even if you ever build a full stack application that deals with authentication, passwords will never be stored in plain text. They will never be readable by a human. They will have to be, encrypted and unencrypted at various points in the process. So, yeah. And if you're curious about that, we have done I've done a couple different projects on here where we actually do that, where we handle authentication and we hash and salt our passwords. Varchar max 255. Yeah. But don't worry about that too much. That's a bit beyond the scope of today's discussion. But yeah, you can read about that at your leisure. Okay, so what does a multi-table application look like? We have a sample application here called tracks_CSV. Shows how these ideas can be combined to parse textual data and loaded into several tables using a proper data model with relational connections between the tables. So we're reading and parsing a comma-separated file called tracks.csv based on an export from Dr. Chuck's iTunes library. All right, so we've got some just raw data from iTunes. We've got a title, we've got artist, we've got album. I don't know what these numbers are, but we'll see in a minute probably. Oh, okay. Title, artist, album, number of plays, a rating, and a length in milliseconds. So in order to store this data, we need to capture each of these items as separate columns, right? But we're going to normalize this information in a way that reduces the number of possible duplicates. So thinking about this logically, we're probably going to want to separate by artist, album, and track. And in each of those, we can say, all right, what is the artist's name? For album, we're going to say, what is the title or the album name? What artist does it tie to? And give each album a unique ID. And then for each track, we need to link each track to the album and the artist. So we're also adding the unique keyword to text columns that we would like to have a uniqueness constraint that we will use in our insert ignore statements. Ugh, I hate that. This is more succinct. Wait, what? This is more succinct than separate create index statements, but it has the same effect. Okay. So we're creating 3 tables and linking them together in order to essentially cut down on the number of possible duplicates. And you might be thinking, this seems like overkill, given the data that we have here. But you have to remember that this is optimized to work with whatever number of records we might have. We could have 1 million records. And at that scale, you're going to start to see performance hits if you have a bunch of duplicate records. All right, let's see what this is doing real quick. I'm just looking ahead here a little bit. Okay, so we're grabbing the tracks file. So now we're back into Python here. We're grabbing the tracks file. We're stripping out the white space. We're splitting it out. And we are checking the length. And for each line, essentially, we are separating out the individual comma separated parts of that line into separate variables. And then we're going to turn around and insert those into the database. Okay, so real quick review here. We're opening this file tracks. And how does Python know when it's reached the end of a line? What does line mean to Python? Bit of a whiplash here. We're going back to Python all of a sudden. No. How does Python know what a line is? Oh, and thank you for the follow, by the way, Naima. I didn't thank you earlier. Naima Roo, thank you for the follow. Yeah, in a just a plain text file or a CSV file or whatever, there's going to be an invisible /n line break at the end of each line. So that's what tells Python, hey, this is the end of a line. So then each line, we're going to strip out the white space. We're going to split it by commas. So it's going to split by commas, like so, into a list. And then it's going to dump each element of that line into a variable. And then we're essentially just going to say, execute multiple insert statements, inserting the appropriate values into each of our tables. So remember how I said earlier that it can get pretty repetitive if you have to insert a bunch of records at once. Now, there's ways to do this in kind of a mass insert type of a way, and a lot of things like Supabase, you can just upload a spreadsheet, but that's not always possible. So in this case, we're automating the creation of these insert statements to say, hey, whatever the current value is that's stored in this variable, put it into an insert statement with the appropriate value. And then we're just immediately doing a select here. And we're retrieving the appropriate artist ID. So we're inserting the value into artist. It's going to generate an artist ID. And then we're retrieving that artist ID and storing it in a variable. And then for album, we're going to insert the title that's currently stored in a variable. We're going to insert the album title that's currently stored in a variable along with the associated artist ID from this insert that we just did. And then from there, we're going to get the album ID. And then finally, we're going to insert or replace into track the title of the track, the album ID, the length, the rating, and the count from these variables, along with the album ID from the record we just inserted into album. So that was kind of a lot, right? That was a bit intense. But all we're really doing here is creating those relationships between the artist, the album, and the track. Artist, album, and track. So for each one, when we insert into artist, it's going to generate an artist ID. So we want to retrieve that and store it in a variable. And then in album, in order to link the album to the artist, we need to include that artist ID in our insert statement as a what? If artist ID is the primary key of artist, and I want to create a link between album and artist, if I insert the artist ID into the album table, what do we call this here? Yeah, it's a foreign key because it references the primary key of our artist table. And the same with track. We're inserting into that the album ID, which is the foreign key as a reference to the album table. Okay? We start from artist because we need the artist ID to insert the album, and we need the album ID to insert the track. If we look at the album table, we can see that the entries were added and assigned a primary key as necessary as the data was parsed. We can also see that the foreign key is pointing to a row in the artist table for each album row. So if we do the correct joins, we can get all the data from all the tables. So how do we do that? We say, well, select star from track, join to album on the foreign key to the primary key, join to artist on the foreign key to the primary key, and then that will retrieve all the fields from all the tables and preserve their relationship. So 3 tables and 2 one-to-many relationships between the tables. What does the limit 2 do? That's a great question. If you were to just guess, what do you think it might be? If we were to set a limit, what do you think that might do? We're doing a select, and then we're putting a limit on that select. What do you think that might do? Yeah, it limits the results to only 2 rows. So you can see here, and this is not the best way of displaying it, but here's one row, and here's the second row. Yeah. So again, plain English pretty much does what it says on the tin. You can set a limit value, and it could be limit 10, it could be limit 5, whatever. But you can set a hard limit on the number of records that you want back. And that can be really useful sometimes, especially if you, let's say you're sorting by like, I don't know, transaction total, and you only want like the top 10 transactions. You don't want to see all 100,000 transactions. You just want, give me the top 5 highest grossing movies of the past year. And so you could just say, write a SQL query for that and say limit 5. That would give you the top 5 for the past year. Yep. And that can be super useful, especially if you're working with data that you don't know very well. So if you're working with a very large table, maybe that has a lot of columns, and you're like, man, I really don't know what this query is going to do. I just want to run a query and see what I get. Limits can be really helpful in that regard, because you can just say like, I just want like sample data. Don't give me everything. I might get a lot. I don't know if I'm going to get 10 records or 1,000. I just want a couple records to look at. And so then you can say, all right, hard limit 10. Don't give me any more than that. Even if there are more matches, I just want to get a sense of the data. So setting a limit can be super useful, especially if you're working with data you don't know, or a table that has, a few hundred columns. Maybe 5 million rows and in 50 columns. That could be a query that could be pretty intense, and so you can set a limit to make that query a lot easier to execute. Poingalis, thank you so much for the follow. All right, home stretch, folks. I know this has been a tough one, but we're almost there. Okay, I'm just gonna really kind of scan through this a little bit. We're getting a little bit intense here in terms of database design, and I really don't think that's necessary for like a basic understanding of SQL. So I don't mean to limit what I'm teaching here, but I'm just kind of skimming ahead a little bit, because a lot of this stuff, most of you will never have to care about. This is very much like architect style stuff. I'm just scanning through here to see how crazy it gets. Okay, I guess this is the last topic, so we'll go ahead and cover it. But again, this is kind of architect style stuff. If you're curious about data modeling, you can read more about it. But really, in general, the whole idea of database normalization is just, if you find yourself with a lot of duplicate records, think about how you can logically split that data up into multiple tables of similar concepts, right? The columns in each of your tables should have a relationship to each other. They should have a logical relationship to each other, right? The artist table should have information only pertaining to the artist. The album table should only have information pertaining to the album. The track table should only have information pertaining to the track. And if you need to combine that data, you should be doing it using joins. I mean, that's really the fundamental concept here, is that your data should be split up, divided logically into individual tables that reflect the characteristics of what they're depicting, whether it's cars or people or, passwords or, locations, right? Those can all be separate tables, and then you can do the appropriate joins with the appropriate keys to combine that data in your results. That's the overall gist of it. But we'll go ahead and talk about mini. Thank you, Dave. I'm glad you're liking it so far. SQL is very fun. This is a bit more of an intense deep dive than I was expecting. But for the most part, if you're using Python for data analytics, you're not going to have to worry about building your own stuff. Now, I know a lot of you are developing like full stack web applications. And so you are going to need to think about data normalization. A lot of that is going to come from trial and error as you're building your project. You might start out with just one table. Yeah, you might start out with just one table, right? And everything's in that one table. But then you're like, oh, wait, I don't want to put I don't want to have, usernames and passwords in the same table as like just my regular user information. Or I don't want to have the same user's name printed on every, form they submit on my application, right? Once they create an account, I only want to store the user information once when they create their account. And then each time they interact with my application and submit a form or click a button, I can just reference that user table over and over again and get everything I need from there with a join. So that's kind of how you think about, applied normalization. All right, but let's talk about many-to-many relationships. Well, we've talked about one-to-one, and we've talked about one-to-many relationships, but many-to-many is the weirdest one. So some data relationships cannot be modeled by a simple one-to-many relationship. For example, let's say we're going to build a data model for a course management system. There will be courses, users, and rosters. A user can be on the roster for many courses, and a course will have many users on its roster. So me as a student, I could be participating in multiple courses, but a course will then subsequently have lots of students in it. So it's pretty simple to draw a many-to-many relationship. We can see here, we've got our course table and our user table, and we've got our little crow's feet here depicting the many-to-many relationship. But how do we implement that relationship using primary keys and foreign keys? So we can create a table called course. It's got an ID, a title, and student IDs. So this allows our course table to link to multiple students. But unfortunately, SQL does not support arrays. So we could try to say, hey, put all the student IDs in one field, right? Just have a whole big list of student IDs for one single record. That would be great, right? But SQL does not support arrays, or at least natively it doesn't. Or we could just make a long string and concatenate all the user primary keys into a long string separated by commas. So we could say, all right, course title is this, and then all the students are listed as just one string with a bunch of commas. You could do that, maybe. But this would become very inefficient because as the course roster grows in size and the number of courses increases, it becomes quite expensive to figure out which courses have student 14 on their roster, right? Because you'd have to comb through every single one of these IDs just to get to student 14. Imagine if you had 200. You'd have to look through every single one of these just trying to find student 14. So instead, we may need to create what's called a connector table. So this can also be called a junction table, a through table, or a join table. And this table is just going to serve as kind of an intermediary. Going to kind of serve as an intermediary between our two many-to-many tables. Where did it go? There it is. So we can still have our course table with the title, and we can have our user table with all the users. And so these are just one record for each course, one record for each user. And then our member table only contains a list of course IDs and a list of user IDs. So The purpose of this table is to capture the connection between a course and a student. One course and one student. Thank you for the follow, by the way, Savar and Poingalis. In a sense, the table sits between the course and user table and has a one-to-many relationship to both tables. By using an intermediate table, we break a many-to-many relationship into two one-to-many relationships. Databases are very good at modeling and processing one-to-many relationships. Hi, Savar. Welcome to the stream. So, in our user table, we have the ID and the name of each user. And in the course table, we have the ID and the name of each course. And then in member, we have user ID, course ID, and we set a primary key as the combination between user ID and course ID. So why would we do this? Why is this better? Why would we do this? Why is this better? Keep in mind the data type that we have here. Based on what we know about performance and how things link together, why is it better to create a third table that links together our user table and our course table? Yeah, integers, right? These values are being, basically the largest bulk of our values are going to be stored as integers, which are a lot easier for the database to work with. And each user ID is only going to reference one record in the user table. And each course ID is only going to reference one record in the course table. So all these strings only have to be listed once, whereas we can have all these combinations spelled out in integers as kind of a reference table or a junction table between these two. Yeah. So following our naming convention, these foreign keys are pointing at the corresponding rows in the user and course tables. And we go through the member table to link to the user table and the course table. So the combination of user ID and course ID is the primary key for the member table, creating a uniqueness constraint for a course ID and user ID combination. So when you're defining a primary key, you can have that primary key be a combination of two different fields or more. I've seen some tables with primary keys that are 5 or 6 fields. I mean, we try not to, but there are times when the only way to get a unique identifier is to smush a bunch of fields together, and then that becomes your unique constraint. The original separate fields are still there, but the primary key becomes a combination of the two other fields. NCL, welcome to the stream. Good to have you here. Now, if we wanted to insert a number of students into the rosters of a number of courses, we might get it in a JSON file like this, which is a list, containing the student name and the course. Then we could write some Python to process that information. And I think this is actually going to maybe come in handy to the project that I'm going to be doing after we finish this course. So I'm going to be taking in a bunch of raw HTML data from a website, structured HTML data. We're going to need to parse it, and we're going to need to extract certain values, things like names and dates, names, dates, characteristics, names of children, names of partners, that type of thing. We're going to need to extract all that information from HTML and then turn around and insert it into a SQL database. So we're going to need to, pull that data out of XML or HTML using Python, format it in such a way that it's structured for a database table, and turn around and insert it into a database. So we're going to be doing literally this. We're going to read the file and insert the members of each roster into the database using the following code. So we connect to our database, we read our JSON, we extract each entry into a variable, and then we create an insert statement to insert it into the appropriate table. Once we've done that, we retrieve the user ID and create the link in the junction table. Now, somebody asked earlier, why wouldn't you just use like the return keyword to, instead of having to do an explicit select to fetch the ID value, why wouldn't you just use the return keyword? You absolutely can do that. In this case, I imagine the author is just trying to simplify things using keywords that we already know. Because there are ways to do this more efficiently, and that's probably what we'll do. We'll be using some more advanced keywords and things that aren't explicitly spelled out in this material to make these queries a bit more efficient. But yes, that's absolutely something you can do. In this case, they're just saying, hey, insert. And then once you've done that, the ID's been generated. Do a select to extract that ID, store it in a variable, and then insert the ID and the title in the next field. And then insert the title in there of the course, store the course ID. So now we have the user ID and the course ID. And then finally, we want to insert both the user ID and the course ID into our junction table. And then once we've done that, we've done the member table. We do not end up with duplicate entries in the member table for a particular user ID and course ID. And then to reconstruct our data across all three tables to see every possible field, we can simply do joins. We can say join member on course ID equals the ID in our junction table. Join user on member on our junction table to the user table, basically fetching all the records that we need in order to match each of those integers in the junction table to a record in the user table or the course table. So here we can see, the connections. We have a lot of repetition, for example, in the course title, but all that's being fetched from one record in the course table. Same with the names. Those are all being fetched from their single record in the user table. So how do we model that? Well, this join table or junction table is actually the simplest form of a join table. It's quite common to want to add some data to the connection itself. So, for example, we might also have a role table or a role as well for each user that is assigned in each course. If we try to solve this by adding an instructor flag to the user table, we'll find that this does not work because a user can be an instructor in one course and a student in another course. If we add an instructor ID to the course table, it won't work because a course could have multiple instructors. And there's no one-to-many hack that can deal with the fact that the number of roles will expand into roles like teaching assistant or parent. But if we simply add a role column to the member table, we can represent a wide range of roles and role combinations. So in this case, we're just adding an additional column there. And 0 in this role means student, and 1 in the role means instructor. So if our JSON looks something like this, we can see that each student could have, or each person could have a role of a student or instructor. And we can simply modify our code to insert that role into the member table as an additional column. In a real system, we'd probably also build a third role table and make the role column in member a foreign key into the role table. Yeah, that's what I was thinking it was going to do. So you'd have a table for users, a table for courses, and a table for roles, and you just do a lookup against each one of those. Okay, whew, that was a lot, right? But I think overall, the one thing that you should remember is, or the one thing that you should, if you want to learn SQL, unless you're building your own full stack application, you probably aren't going to have to worry much about actual database design. What you should know how to do, at minimum, every developer should know how to write a basic select statement and how to join tables together. So one thing that I'm really surprised it didn't talk about here is the different types of joins that you can do. So I'm not going to go into that, but I do have a stream on that specifically where we talk at length about how to do select statements, how to get data out of a database so that you can analyze it. Because honestly, I think if you're using Python, your goal is to do data analytics probably. And so how do you write a good select statement? So I have streams on that on my YouTube channel. I actually have a SQL playlist on my YouTube channel. So if you just head to my YouTube channel, check out my SQL for Beginners streams. I think you might find that's a little bit more approachable than what we just talked about, especially in terms of just how do I write a statement? How do I do basic CRUD operations with SQL? How do I interact with a SQL database that already exists? So head over to my YouTube channel. You can do exclamation point YouTube if you'd like a link to that. Head to the playlist tab. Got a SQL playlist there. Check it out if you want to learn just enough SQL to be dangerous. And we also have a little bit of fun in those streams where I talk a little bit more about destructive operations. So what's the difference between a drop table and a delete? How do I make sure that I'm writing a safe delete statement if that's something I'm allowed to do? How do I write good insert statements? How do I write good where clauses on my statements? What are the different types of joins? What's the difference between an inner join, a left join, a right join? When should I care, right? What does it matter what type of join I'm doing? So in general, I think those, like learning how to write good statements is going to be more important than database design, especially if you're trying to do analytics with Python. But that's just me. Still, I mean, this stuff is good to know, but for a beginner level, not so much. I'm glad you knew the SQL streams, Rocks. Yes. Now we are going to do some exercises on this, but we're not going to do them today. We're going to do them next week. And see how much we remember in terms of how we write good statements. And we're also, I think, going to get to build our own interface with a map API as well to display map points. Or maybe that's not until the following week, but I know it's coming up. I was pretty excited about it. We're going to get to like sort of build a API call where we're displaying different points on a map, which should be pretty cool. I've always kind of wondered how that works, so I'm excited to try it out. All right, so I know that was a lot, but does anybody have any questions on what we've just covered in terms of SQL? Could be about anything we've covered so far. Could be what's the best way for me where should I build a SQL database? If I want to build a full stack app, how can I build a SQL database for free? How do I do a join? How do I know what to write in terms of SQL? How can I learn more about SQL? So does anybody have any questions on those types of things? Can you start from the beginning? Hey, that's what recordings are for. That's what recordings are for null recall. Gosh, I can't even talk anymore. Been going for so long. And let's see what the next thing is. I think we're almost done with this course, folks. Yeah, so the lesson we're going to cover next week is the last lesson in the course, my friends. So we've done very well. Oh, Suri says, this has been so informative. I was just browsing Twitch channels and came across yours and got sucked in. Oh, that's great. I'm glad you learned some stuff. That's the goal. Null says, I see we're nearing completion of the course. Any insight on what's next? Yes. We are immediately going to turn around and start building a real world project. My entire goal with taking this course was to accomplish a project that I have been wanting to do for a local volunteer organization that I work with. I'm building them a full stack web application. And we'll talk more about it like once we get into the project, but essentially I need to scrape a large amount of data and convert that data into a bunch of database tables, or one table. Probably it's only going to be one table. It's not going to be a complicated database, but really I just need to put the data in a database and make that data searchable. So it's going to have a front end, database backend with a large number of records that I've scraped from the internet. And that needs to be searchable and also needs to have full CRUD capability. So create, read, update, delete on existing, records. Create, read, update, maybe not delete, but yeah, I need an interface to a database with full CRUD capability and a SQL backend. using web scrape data. So really, I mean, Python is the perfect tool for doing that. I had originally tried to approach the project without knowing Python and was trying to parse the HTML that I scraped by hand, and that sucks. So Python is going to come to the rescue here in terms of formatting that data and getting it into my database. Yeah. Noel says, "Oh, we get to help with that. You do. You all will get to help me put this together and get it up and running." D-Rock says, "Mark is deleted." Yeah. I'm still toying with the idea of whether I want people to even have the illusion of being able to delete something. Marking things as deleted, giving them a deleted flag and hiding the records is pretty common. I'm still not even sure whether I want to do that. We'll talk more about it once we get to the project. But yeah, I imagine it would probably be more of a modify type situation. Soft delete, yeah, essentially. But yeah, essentially what the project I'm working on is going to be hosted for free because this organization has literally no budget, but it should be beneficial to the community. And it's going to be a fun project for me too to really help cement my understanding of Python. Any other questions, folks? Great question. All2 says, "Where is a database hosted in a full stack app? I've only ever used SQLite." Yeah, so you have a variety of options. There's a lot of great cloud-based solutions out there. Personally, I highly recommend Supabase, Supabase. It has a free tier. You can pay for more access if you want. But essentially it's a cloud relational database solution. And what I really like about it is that you can interact with it no matter how much SQL you know or don't know. So you can choose whether you want to interact with it in like a GUI format, interacting it with a very visual format, or you can write raw SQL and execute it. So even a mixture of the two. I've done it as a mixture before where it's like, okay, well, this is easier to do in the GUI, and this is easier for me to just write a SQL statement to do it. It also has a wide variety of like levels of security that you can put on your data. So it has like row level security. You can really lock down your data, or you can open it up. It's really up to you. And like I say, it's free. All that is free. And there's paid tiers for higher levels of access. But I mean, if you're just building a little, like for the app that I'm building, that's probably going to be accessed, at maximum, like 100 times a week, if that. I'm just going to use the free tier. Yeah. Stretch there. Thank you for that. So yeah, Supabase is great. I've actually used Supabase here on stream a couple times. So if you just like go to my YouTube channel and search Supabase, you can kind of see it in action as we use it for a couple things. But yeah, super useful. You can build out your own database. You can build out multiple databases. I think it limits you to like 2 or 3 projects at the free tier, but I mean, what more do you need, right? And you can have, unlimited tables in each of those projects. So yeah, pretty great. Caden Road, thank you so much for the follow. Good to have you here. And yeah, so if you're building a true, like accessible from anywhere, full stack type application, I would use a cloud solution like that. But as Holly mentioned, if you're building, something more local, then yeah, you can host a local database right on your computer. You can spin up a Postgres database, host it on your computer. You can do the same thing for MongoDB too. You can have a local MongoDB database, and it would just be local to your machine. So whether you go with cloud or local is really up to you, depending on your use case. So if you're building something, for you personally, or for, people in your household, or it's going to be low usage, then you might just be fine with just a local database. But if it's going to be if it should be accessible from anywhere by anyone, then you probably want to go with cloud. Yeah, great question. But yeah, Supabase is by far the best solution that I found for relational database cloud hosting. I mean, honestly, if they offered me a sponsorship, like I would do an entire stream just like singing their praises because I really, really like them. I've been trying to angle for a Supabase sponsorship for a while. Any other questions, folks? Oh, while you're thinking about it, I'm going to have another Jaffa cake. Delicious. You can ask this is the off topic question time. You can ask off topic questions too. Ooh, good question, Holly. SQL versus no SQL. Yeah. So, obviously, I'm going to have a bias personally because I've been working with SQL for over 10 years now. But I've also worked with NoSQL. So I will say it's the right tool. You got to find the right tool for the right job, right? Each of those exists for a reason. SQL exists for a reason. NoSQL exists for a reason. SQL is the OG, right? Relational databases are literally everywhere, and they have been for the last 50 years. Relational databases pretty much power the world. If you encounter a database, there's a high probability it's going to be relational. That's why I recommend that everybody learns a little bit of SQL, because odds are, if you encounter a database, it's going to be relational, and you're going to need to know SQL to access it. However, relational and non-relational are, have their place. So NoSQL databases can be useful in other ways. If you have non-structured data that has, it's just never going to be strictly formatted, right? Each transaction is going to be different. You're going to have a high degree of variability, or your data is really changing along all the time. You're constantly adding more fields, you're constantly removing fields, that type of thing. That can be a real headache in a relational database because you're trying to relate records that truly don't relate to each other. If you have records that are truly independent, you're taking in just garbage data or data that's highly variable. That is a nightmare for relational databases. It just doesn't fit that template. And so if you have that kind of data, that highly variable data, then a non-relational database, a MongoDB database or something similar, is exactly going to fit your bill, because you're going to have just a bunch of individual documents or individual objects that you could relate together if you wanted to, but it's not required that you do so. And you can still capture all that data and store it, but it doesn't have to be related. It can just sort of live in a bucket with other documents and other objects. Yeah. So each has their place, right? You'll find that, things like social media applications may use other types of databases entirely. Things like I'm spacing on the name. Not graphical. Graph, what is it? Like GraphQL. Yeah. Like GraphQL databases. Those are more like really complex star relationships between data. Yeah, GraphQL. That's it. Yeah. Though that's even a different database type where you have a high level of relationships, even higher than a relational database. Because think about social media, right? You're going to have comments which are related to a person, when that person has friends and each comment has likes. It's an impossible number of relationships for each element that you're inserting. And so relational and non-relational databases just don't work for that. And so that's a whole different kind entirely. Or you could even have things like time-based databases, sequential databases. There's all sorts of different less common types that may fit the bill. They all exist for a reason, and they all generally have pretty specific use cases. But by far, the most common type you will find are relational databases. Let me see here. I'm got to catch up with chat. No, Rico says, I'm pretty sure Jaffa cakes are like Thin Mints, serving size is one sleeve. Yeah, having eaten an entire sleeve of Jaffa cakes, I tend to agree. Yeah, Supabase does host Postgres databases, yes. So If you're using Supabase, you will be interacting with it using the Postgres flavor of SQL. Safety says, as a SQL dev, would you have done anything different in your learning and career growth? Any concepts you would recommend prioritizing? I mean, honestly, I kind of stumbled into this. It was really, a series of random accidents that kind of led me down the SQL path. So, of course, if I had intended to become a SQL developer from the very beginning, I would have focused on a lot more of like the underlying concepts, like, database efficiency and tuning, and, focused a lot more on complex query concepts a lot sooner. Things like subqueries and CTEs and, complex built-in functions. And, I would have been a lot more intentional about it rather than just kind of stumbling along and landing in more and more complex SQL roles over time. I just would have been more intentional. As far as concepts, yeah, I would have prioritized query efficiency and database tuning, especially at the enterprise level. The efficiency of your queries starts to matter a lot. Whether a query takes 5 seconds or 30 seconds kind of becomes a big deal. And so, yeah, I would have learned a lot more about that. We've got someone on our team now who kind of went that route, like the more traditional computer science route, has, kind of studied query efficiency from the very beginning. And you give him a query and it's amazing the things he can do. He builds like these complex stored procedures that are just beautiful and execute such complex operations at such a high level, like processing millions of rows super quickly and just tuning the crap out of these tables. And it's just really incredible to watch what he can do. And, I wish I would have done, more of that. But hey, the way I stumbled into this, it just sort of made that impossible because I did not have this career in mind when I started out. So, hey, we work with what we got, right? Mattel says, don't most NoSQL DBs have a SQL front end of interpreter? Not necessarily. I mean, they can. You can use SQL to query a NoSQL database, but you don't have to. You can use something like Mongoose to query a MongoDB database, and it uses something that feels a little bit like SQL, but has a very different syntax and can do different stuff. So it isn't SQL. Neil says, I wish 5 hours at work moves as fast as 5 hours in the stream. Hey, me too, my friend. Suri says, do you have a stream schedule? Yes, every Sunday at 3 p.m. Eastern. So whatever that looks like for you, that's my schedule. Every Sunday, 3 p.m. Eastern. Killer says, when you're on a site, sometimes you write down an email, phone pastes it like this with a capital letter and a space on the end. Why does the phone format it like this? Doesn't the website should handle it and convert it to lowercase without spaces? Yeah, so the reason why that happens is your phone is trying to format it like a sentence, or like a name, like a capital letter first. Because generally, when you first start typing something, it's going to be the start of a sentence, like probability-wise. So your phone is going to auto-format it like a sentence with a capital letter. And then at the end of a word, it's going to automatically, it thinks that's a word. It doesn't know it's an email necessarily. And it thinks it's a word. And so it's going to auto insert a space so that you can just keep typing. You don't have to hit the space bar. You can just keep typing without pausing. And so it's trying to help you there. But yeah, in the case of an email, it's not. Yes, a website could auto format it, could strip out the white space, could, convert it to lowercase when you submit the form. That would be good data sanitizing, but you'd be surprised how many people just don't bother. It's not hard to do, but most people don't bother to do it. So, yeah. Yes, it's very easy. You can do a simple, lower conversion and strip, strip or trim those extra white spaces. But whether or not they bother is kind of a crapshoot. Duchess says, I think the devs at my company keep complaining about having to use stored procedures. Again, it depends on the quality of the procedure that's being written in the first place, right? There's pros and cons to storage procedures. Stored procedures, for everybody viewing, stored procedures are kind of like programs in other languages. They are literally procedures or series of operations that are stored. So you can call them kind of like you would a function, and it's going to perform a series of operations in SQL. So it's going to execute a series of SQL operations. They're often fairly complex. They often perform a series of complex operations in sequence, like in a very specific sequence, X, Y, Z, and they have to happen in a specific order. And yeah, they can be kind of hard to understand and hard to modify. So depending on how they're written, it could be that, the devs don't like using stored procedures just because they don't quite understand what's going on under the hood, and it's confusing, or it doesn't give the correct results and they don't know how to fix it. So I've seen it be used for good and for evil. Oh yeah, some websites can handle them. Some say like, boo, you wrote it wrong. Yeah. And that really just depends on how they want to parse their data. I would say it's easier to make a form reject data that doesn't fit the template than it is to actually properly sanitize the data on the other end. So it sounds like they're probably just taking the easy way out. Duchess says, I think they're biased because they don't know how to write them properly, referring to stored procedures. Yeah. I mean, that's basically what I was saying, right? Is if you write good stored procedures, they can be super useful. I worked at a place where the person who wrote our stored procedures was like a freaking genius. Like I learned most of what I know about SQL from him. And he wrote just incredibly elegant stored procedures that would be executed thousands of times a day automatically. Like we had automations that would just fire these stored procedures off, and it was so cool because they always worked. And they did these incredibly complex routing operations and all these types of things, and they just worked. And so, but I've seen sometimes when, somebody will build something and it doesn't behave the way you expect. And especially if it's firing automatically, you can end up in a real bad spot without knowing what's going on or why it's happening. So it can be a blessing or a curse depending on how you use them. Yeah. All right. Anything else, folks? Big Odini, thank you so much for the follow. And Brandora's Box, thank you for the follow. I like that name. That's great. Brandora's Box. Very clever. And I know this was a long one today, so like I mentioned, these streams are recorded. You can go to the videos tab right now on my Twitch channel, and you can watch this recording from start to finish. Or you can wait a little while, and this entire series is going to be up on YouTube ad-free on my YouTube channel. So you can watch it at double speed. I know a lot of people do that. They'll speed it up to 1.5 or double speed to get through the material faster. And you can watch it on YouTube ad-free. Of course, sir. It was great to have you here. Of course, Duchess. Thanks for being here. All right. I'm going to start looking for somebody to raid. But if you have any questions, please do feel free to ask them. It's all good. I know we had a lot of new people here today, so I'm glad you're here. And if you have questions for me, please do ask. I'm just going to be pulling up the raid screen in my other monitor, because then we always like to pick who to raid kind of together. So I'll show you the raid list, and we'll find somebody, or I can, hand you all off. Okay. All right, let's look at our raid candidates. As always, if you have somebody that you would like to suggest, preferably in the software and game dev category, please do point them out and we'll take a look. Also, preferably someone who's smaller. So, there's a lot of great, huge streamers out there, but we always like to celebrate the people who have, a small audience that we would like to grow. So we're going to do similar, smaller size and same category. Code 807. This might be interesting. Looks like they're doing some game dev. Ooh, got some automation here. Doing some support. Making a VR game. Webcomics. What is this person doing?
No conozco, señor.
Let's see, is this an English language stream? I'm trying to see. Okay, this might not be an English. Okay, so this is not an English language stream. We do prefer. There's lots of other folks who are, streaming in not in English, but we do prefer to raid English language streamers, just so that we can interact with them in a meaningful way. Not that I don't have anything against people who are streaming in other languages. I just don't speak those languages, and neither do most of the audience. So we like to be able to interact with the people we raid in a meaningful way. Oh, Pete reincarnated a Python dev. What's this one doing? Of course, killer code. They don't look like they are. Oh my goodness, 16-hour stream. Wow. Yeah, they look like they might be taking a break. Okay, there was this person. I'm actually kind of interested in what this person is doing. Yeah. Let's maybe check out this person. They look like they might have some fun interaction elements. It looks like they might be, I think they're coding a Twitch bot. So if we give them a raid, we can help them kind of test their Twitch bot thing that they're doing. It looks like they've got these kind of balls that fly around. So we can help them out, test it, and see what they are up to and give them some encouragement. Okay, so before we raid them, as always, please give them the same respect that you give me. Give them the same positive vibes that you give me. Interact with them the same way you would interact with me, and show them, this awesome community that we have here. So yeah, sounds interesting. Absolutely. Hey, Code Cannon, we are just getting ready to toss folks off to a raid. So feel free to stick around to the raid. This person looks like they're doing something pretty cool, building a Twitch bot. So let's go give them some positive vibes. All right. I'm probably going to drop off pretty soon after the raid. I got to go eat some food that's not Jaffa cakes because I've had way too many Jaffa cakes today and I need some real food. So I'm going to go do that. But please do enjoy what this person is working on and give them some positive vibes. Alrighty, folks. Raid is going to start shortly. I will see you all next week for the conclusion of the Python course. We're going to be doing the last lesson next week, people. Data visualization, which should be really fun. Doing some data viz, doing some graphs, maybe doing some pandas, and really learning how to put some visuals to all this data we've been working with so far. So should be a blast. I will see you all next week, and have a great week, folks. Sunday at 3 p.m. Eastern next week. See you there. Alrighty. Bye-bye. Raid is starting now. All right. 7, 6, 5, 4, 3, 2, 1, and raid. Bye-bye.